Mati. Ya, kaatad തന്നെ എന്തോ
Hello, everyone. Good morning. So, why the program is delaying?
Very good morning to all of you. From the NSF side, Mr. Tilna Kumari Kandanmulla will start the program now. Thank you.
Good morning and connecting while she will be connecting a little while. Until that we can proceed to start today's webinar. As per the agenda, the first item is the welcome. I cordially invite Engineer Granny Jalat, Vice President of ISL, to deliver the welcome address. Over to you, sir.
Okay. Good morning, everybody. Dear all participants, ladies and gentlemen, you all are welcome to this online webinar on different facets of salinity affecting in Sri Lanka and solutions for those problems. This webinar had been organized by National Science Foundation of Sri Lanka in collaboration with Sri Lankan Association for Advancement of Science and the Institution of Engineers of Sri Lanka. I take this opportunity to thank all partners involved in organizing this webinar. Unless their enthusiastic effort, this event won't be this much successful. Today, soil salinity, we know it had been a major global issue, mainly due to its adverse impact over agricultural productivity and sustainability. In the context of Sri Lanka, salinity problems are primarily associated with coastal areas and within irrigated lands, particularly in the dry zone. Perhaps excessive irrigation, inadequate drainage, seawater intrusion due to sand mining probably would be the main causes of salinity. Literature confirms that approximately 40% of the world's irrigated areas are affected by salinization. So prevailing status clearly warrants the need to share knowledge on desalination in soil and viable interventions for this problem. I sincerely hope that this webinar will help to disseminate alternative solutions which would help to derive workable action plans to these problems. Without taking that much of time, with the short welcome note, I hand over the session to the coordinator to proceed on with the webinar proceedings. And once again, I thank you for inviting me to express the welcome note. And I wish you all a very interactive sessions on salinity. Thank you very much.
Thank you very much, sir, for your kind words on the welcome address. The next item is, it is done by the Professor Ranjit Sanaratna, the chairman of the National Science Foundation. Over to you, sir.
Good morning and good evening. Those who are joining from the stage, Professor Jayanta, Bisekara and others. I am truly delighted that NSF jointly with SLAS and IESL has organized a webinar on a topic of great relevance and value, that's on the salinity. And as also mentioned before, during welcome address, salinity is affecting large expanse of land around maybe over 10% of total land area in the world, and also in Sri Lanka over 3%, which may exceed even 225,000 hectares. While natural processes contribute to the salinity, this anthropogenic impact has been huge, mainly due to unscientific and unsustainable practices. So because of this salinity, in addition to affecting the productivity, especially agricultural productive land, it poses a host of other issues like reduced biological productivity, reduced green cover, reduced biodiversity, and also it adding to climate change and making the environment very inhospitable. We know that the salt affected areas are very hot and also very dusty, and also this condition affect the recharge of groundwater. So this is actually posing threat to humanity. So there's a need to arrest and reverse the impact of salinity, which is leading to desertification. It is happy to see a galaxy of high-profile scientists from home and abroad have assembled at this webinar to deal with the key aspects of the causes, these effects, and mitigation and prevention measures. So actually, the National Science Foundation has joined forces with SLAS, Sri Lanka for the Advancement of Science, IESL, the Institute of Engineers, and the universities, and also Sri Lankan expats abroad. That is really a salient feature. We draw upon the expatriates overseas in an issue of national interest. So this is a multidisciplinary approach being adopted here. We also want to mention that National Science Foundation has recently established a digital platform so as to harness the Sri Lankan expatriates for national development. We know there are over 3 million Sri Lankans living abroad. 50 to 25% of them are scientists and professionals depending on the country. And our digital platform has already been able to get linked to over 600 high-profile scientists and professionals. And we would like our Sri Lankan scientist professionals, both in the public and private sector, to link with our Sri Lankan expatriates who are really looking forward to working in a mutually rewarding way. That way, we would be able to address our national issues more effectively and impactfully. I don't want to take more time. I see a very rich and exciting agenda in place. And my appreciation to Professor Jayanta Bisekara for joining us. I know it is now nearing midnight in the States, joining us there, and all other scientists joining from a host of institutions in the country, and including Department of Agriculture, Department of Irrigation, Columbia University, Open University, and IESL, Water Forum, and so on. So again, my appreciation to all joining this webinar, and I wish this webinar great success. Thank you.
Thank you, sir. Actually, sorry for the interruption. There was a technical difficulty. Okay. Our next speaker is the engineer Bhadra Kamaladas. Actually, if we mention her background, she's graduated from the University of Moratuwa in 1978 and in the civil engineering stream, and obtained Master of Development Technologies from the University of Melbourne, Australia in 1994. She retired from the government service as the Director General of the Irrigation in 2015. She has published more than 30 technical papers related with water resources development and management. Engineer Bhadra Kamaldas is the current chairperson of the IESL Water Forum. So I would like to invite her to deliver her presentation. Over to you, madam.
I'm sorry, there was a issue with. Can you hear me, Tilina?
Yes, we can hear you. Yes.
Yeah, sorry about that issue. Thank you very much, Tilina, for the introduction, and good morning to all of you. Thank you very much again for giving me this opportunity to represent the Water Forum of Institution of Engineers Sri Lanka. So I intend to share general overview of this subject today as a prelude. The salinity in water may occur due to natural causes or man-made issues. Under whatever situation, it will make negative impacts to any sector. We can further define the impacts as short-term and long-term effects that depending on the intensity and the characteristics of the substances that made the change. So I would like to quote few examples today at this webinar. That will be the initial fact-finding platform. I hope this webinar will be for the researchers and the practitioners to get together to find the solutions. So my first focus is to the coastal belt of Sri Lanka. As an island, we are very much vulnerable for natural seawater intrusion to both the surface and groundwater sources. This will aggravate due to the topography of the country that form the land area into 103 river basins and 94 coastal basins. Not only the river mouths and river beds, but considerable area in coastal belt is flat and closer to the mean sea level. So salinity intrusion along the rivers and to the groundwater is inevitable. Impacts will change seasonally due to the tidal action, but the worst scenario will be due to the sea level rise as a climate change impact. We have to remember that densely populated Jaffna Peninsula as well as Kalpitia are drainage basins, so that are not having the perennial rivers. Totally, those are totally depend on rainwater and groundwater for their all water needs. Groundwater resources have already been contaminated in both areas. Excessive pumping for agriculture has made the groundwater level lowering, that in turn allows the saltwater intrusion. So those are the issues in broad. So in 1940s and 1950s, Irrigation Department constructed barrages at Vadamarachi Lagoon and Uppuaru Lagoon to convert them into freshwater lakes. This was a promising solution, especially to the agriculture sector in those areas. However, the infrastructure became disused during the wartime as proper maintenance was not there. Tondamanaru Barrage was, you can see the photograph, that was restored again in 2017 again, and the result is just yet to come. As another example for natural salinity, I would like to quote, it's a giant tank irrigation system in Mana, where I got some photographs from the engineer working there, where the steel gates are needed frequent replacement due to the impact of saline water intrusion to the system. This is a common occurrence not only in giant tanks, in many irrigation systems alongside the coastal belt all over the country. Amongst the man-made salinity issue, the most critical issue what I see is excessive sand mining, as mentioned in previously, in the rivers. That made unaccounted damage to our whole ecosystem, infrastructure, and ultimately to the country, the economy of the country. Some of you may wonder on what basis I made this statement. You can see how excessive sand mining has deepened the riverbed in Kallan River in this graph. The riverbed at Hangwell is below the mean sea level by 2005, which was not so in 1988, as shown in the graph. So the condition is worse by now after maybe nearly 20 years. So it is the same story, not in Kalani. In all our major rivers, it's the same story. That needs very costly salinity barriers. That is the result of the final result of this damage. Water intakes to our main cities along the coastal belt, Colombo, Gampaha, Kalutara, Gaul, Matara, Nigambu, they face huge threat due to saltwater intrusion, and water supply authorities had to either shift the extraction locations to upstream or construct salinity barriers across the major rivers such as Kalani, Kalu, Gin and Nilwala. The total cost of the economy has never been comprehensively assessed due to these changes. So according to the authentic information I received, the total cost of change in the new water supply in the Kaluganga would be around rupees 8,200 million. This due to the salinity impact of current intake at Ketana, intake of National Water Supply and Drainage Board. Another man-made case is shrimp farming, I can quote, especially in Putlam and Batiklo districts, that was highlighted frequently by the environmentalists. Discharge of effluents from shrimp farm were to be regulated as a result, that is to mitigate the salinity effect to surface and groundwater. I would bring only another case study that brought a lot of attention among the agriculturalists and irrigation engineers. That was the salinity effect occurred for paddy cultivation in Kirillakali sector after constructing Nilwala flood protection scheme. There was a natural pyrites deposits in the area which was not identified properly at the planning stage. So once the pumping started as a part of the flood prevention, this deposit became active, and it takes some time to realize the situation to the scientists and make the remedial measures. So salinity is no more problem in Kirillakali sector, but adopting to the new farming practices to overcome this situation is a challenge to the farmers there at the moment. Okay, what are the solutions we can think of? As for any other subject matter, we have structural and non-structural solutions to mitigate the salinity in the water. These are some of the structural measures I can name which are being practiced in our country as well as in all over the world. As the non-structural measures, the government can impose regulations, or else as responsible citizens and corporate sector, we have obligations to impose self-regulations for all our activities. With that note, I would like to conclude my intervention by handing over the stage to the experts to continue. Thank you very much.
Thank you very much, madam. I think you can unshare.
Yeah.
Yeah. Now, from here onwards, actually, we will be starting our lectures. Our next presentation would be conducted by Professor Jayanta Bisekara, Director of the Sea Level Solution Center, Institute of Environment, Florida International University of USA. But before starting the presentation, I'd like to mention a couple of things. From here onwards, you will, the audience will be listening to 4 main presentations. And I would like to invite all of you to listen carefully. And if you have any questions, you can post them in the chat box. Along within the brackets, you can mention to which speaker you are forwarding the question. and aiming at. And at the Q&A session, the moderator will take up those questions. Now, let me briefly mention the credentials of the expatriate Sri Lankan professional, Professor Jayanta Bisekara. He is the, as I mentioned, he's the director of the, and research professor in the Sea Level Solution Center, and he has won a number of awards and involved in a number of initiatives in the USA. For example, he served on the Federal Advisory Committee, which directed the development of the National Climate Assessment in 2014 in USA, and he is the 2015 recipient of the Norman Medal of the American Society of Civil Engineers. His research areas are climate change, sea level rise, hydraulic modeling, adaptation and resilience, and water management. Okay, with that brief note of introduction, I would like to direct this presentation and I would like to invite Professor Bisekara. Over to you, sir.
Yes, Ms. Tillani, can you see my screen?
Yeah, we can see you. Yes.
Is that the full screen or the presenter view?
Full
you can
screen.
see the full screen. Okay, good. Okay. All right. Thank you. I want to thank Professor Senaratne for that introduction and Ms. Engineer Kamala Das for that nice description of the problems and some solutions. And I also want to thank NSF, SLAS, and IESL for inviting me. Without talking too much about me, Ms. Tillani already introduced me. I will basically focus on the sea level rise and the saltwater intrusion aspects. I believe that's, as Engineer Kamala Das explained, over 90 watersheds or basins around Sri Lanka are coastal basins, and with sea level rise, the saltwater intrusion is going to be significant. So I will talk about facets of saltwater intrusion and climate change, and also in terms of sea level rise scenarios, what should we expect in the future? I also want to talk about some experience we have in the US for monitoring, modeling, and impact assessment, and some ideas from me, basically some potential solutions and possible pathways. So basically, in terms of climate change impacts and including rising sea levels, you can see this little cartoon in the middle showing an idealized area with coastal urbanized region like Miami, for example. And there are multiple threats due to climate change, primarily sea level rise. You have storm surge impacts, saltwater intrusion, and urban flooding, and also natural system impacts like the Everglades. You see all these pictures around to show some of the impacts that we already have. For example, this is a little video that I took. I guess it is not playing, but in Miami Beach. So I'll go a little bit more into the details of this as I go through my presentation. So initially, basically, I want to give you a basic idea about the saltwater intrusion process. You see a cross section of the ocean and the land itself. You have the fresh water on the land side and seawater on the ocean side. And then you have this zone of dispersion. You basically transition from salt water to fresh water. And ideally, to model or understand this zone of dispersion is somewhat difficult. There's not a whole lot of data. And as I will mention later on, in terms of modeling, we assume this has a sharp interface and try to understand with sea level rise what the saltwater intrusion extent or how the saltwater front might move. This is an example depiction of what could happen under sea level rise. You basically have water supply for residential areas or urban areas. And with pumping, you basically have what is known as salt upconing, basically a saltwater front being drawn into the well and basically salinizing the water supply for that community. And to the left, you will see the irrigation wells that are also typically, you will have fresh water, but as the saltwater front is moving, that also, that might have salinized the irrigation wells affecting the agricultural areas. So what are the important factors defining the saltwater intrusion? Basically, you have rainfall recharge, and as we discussed earlier, with climate change, if the rainfall is reducing, recharge will be less, and that will probably induce saltwater intrusion further into the aquifer where you draw water from. That is the flux coming from the regional groundwater flows. And then obviously the head of the water table is also an important factor, and the sea level. So this graphical display or idealized display shows the important parameters, the recharge, the flux, sea level. And then basically we are interested in the saltwater front, which has what we call a saltwater wedge. What happens to this toe as the sea level is rising? And there are a lot of equations for this, for computing this toe. And traditionally, this is coming from over 100 years ago, known as Geibel-Herzberg approximation, basically defined under idealized condition, what is the depth of the saltwater front with respect to mean sea level here. And so if you have a depth of water or head above the mean sea level of H, and your depth to saltwater front is Z, basically it's given by this ratio of these two quantities, basically using freshwater density and the saltwater density. And by substituting those numbers, you basically have this equation, simplified equation. Depth of the saltwater front is 40 times the head of the water table above the mean sea level. And that's a convenient way to kind of get an estimate of, if you, for example, have 1 foot of head above mean sea level for groundwater, basically your saltwater front is like 40 feet below. So this is some of the earliest ways of describing the saltwater intrusion process. Another important aspect in the coastal areas is, when you have naturally environmental sensitive areas, particularly around Sri Lanka, for example, you have mangrove zones or marsh areas. With sea level rise, these marsh areas will be basically converting the salinity regime in those, and naturally they will basically move upstream, or what we call marsh migration, and might impact adjacent land agricultural areas. So this is another example what could happen in environmental sensitive areas. Yes?
Excuse me, this is Banduni. There's a small technical issue due to the number of participants. Therefore, ISL requests us to stop this for 3 minutes and rejoin with the same link once again, because they have given us 100 participants, but there are around 200 participants registered by now. So there are a number of people who are out from this session, and therefore I request all of you, the participants, to re-log in within 3 minutes. Thank you very much. Sorry for these inconveniences. Thank you. So this will stop for a while, and then please re-log in again. Thank you. Sorry, sir.
So do I need to re-log in as well?
Yes, sir, all of us, everybody,
okay.
Because they will increase the participant number to a different one, and then we have to re-log in.
Is that the same link?
Same link, yes. We have to use the same link.
Okay.
Sorry for all the inconveniences. දෙම දාගන්න ඕනේ නැත්නම් බැරි මේක මුලින් කිව්වට අමාරු වෙද්දි මම ඒක අර දඩබඩ ගාලා ආවේ. ලීවින්නේ
I think the participants are connecting. We would like to invite them to log in as soon as possible so that the speaker could continue.
I'm sorry, there was a issue with. Can you hear me, Tilina?
Yes, we can hear you. Yes.
Yeah, sorry about that issue. Thank you very much, Tilina, for the introduction, and good morning to all of you. Thank you very much again for giving me this opportunity to represent the Water Forum of Institution of Engineers Sri Lanka. So I intend to share general overview of this subject today as a prelude. The salinity in water may occur due to natural causes or man-made issues. Under whatever situation, it will make negative impacts to any sector. We can further define the impacts as short-term and long-term effects that depending on the intensity and the characteristics of the substances that made the change. So I would like to quote few examples today at this webinar. That will be the initial fact-finding platform. I hope this webinar will be for the researchers and the practitioners to get together to find the solutions. So my first focus is to the coastal belt of Sri Lanka. As an island, we are very much vulnerable for natural seawater intrusion to both the surface and groundwater sources. This will aggravate due to the topography of the country that form the land area into 103 river basins and 94 coastal basins. Not only the river mouths and river beds, but considerable area in coastal belt is flat and closer to the mean sea level. So salinity intrusion along the rivers and to the groundwater is inevitable. Impacts will change seasonally due to the tidal action, but the worst scenario will be due to the sea level rise as a climate change impact. We have to remember that densely populated Jaffna Peninsula as well as Kalpitia are drainage basins, so that are not having the perennial rivers. Those are totally dependent on rainwater and groundwater for their all water needs. Groundwater resources have already been contaminated in both areas. Excessive pumping for agriculture has made the groundwater level lowering, that in turn allows the saltwater intrusion. So those are the issues in broad. So in 1940s and 1950s, Irrigation Department constructed barrages at Vadamarachi Lagoon and Uppuaru Lagoon to convert them into freshwater lakes. This was a promising solution, especially to the agriculture sector in those areas. However, the infrastructure became disused during the wartime as proper maintenance was not there. Tondamanaru Barrage was, you can see the photograph, that was restored again in 2017 again, and the result is just yet to come. As another example for natural salinity, I would like to quote, it's a giant tank irrigation system in Mana, where I got some photographs from the engineer working there, where the steel gates are needed frequent replacement due to the impact of saline water intrusion to the system. This is a common occurrence not only in giant tanks, in many irrigation systems alongside the coastal belt all over the country. Amongst the man-made salinity issue, the most critical issue what I see is excessive sand mining, as mentioned in previously, in the rivers. That made unaccounted damage to our whole ecosystem, infrastructure, and ultimately to the country, the economy of the country. Some of you may wonder on what basis I made this statement. You can see how excessive sand mining has deepened the riverbed in Kallan River in this graph. The riverbed at Hangwell is below the mean sea level by 2005, which was not so in 1988, as shown in the graph. So the condition is worse by now after maybe nearly 20 years. So it is the same story, not in Kalani. In all our major rivers, it's the same story. That needs very costly salinity barriers. That is the result of the final result of this damage. Water intakes to our main cities along the coastal belt, Colombo, Gampaha, Kalutara, Gaul, Matara, Nigambu, they face huge threat due to saltwater intrusion, and water supply authorities had to either shift the extraction locations to upstream or construct salinity barriers across the major rivers such as Kalani, Kalu, Gin and Nilwala. The total cost of the economy has never been comprehensively assessed due to these changes. So according to the authentic information I received, the total cost of change in the new water supply in the Kaluganga would be around rupees 8,200 million. This due to the salinity impact of current intake at Ketana, intake of National Water Supply and Drainage Board. Another man-made case is shrimp farming, I can quote, especially in Putlam and Batiklo districts, that was highlighted frequently by the environmentalists. Discharge of effluents from shrimp farm were to be regulated as a result, that is to mitigate the salinity effect to surface and groundwater. I would bring only another case study that brought a lot of attention among the agriculturalists and irrigation engineers. That was the salinity effect occurred for paddy cultivation in Kirillakali sector after constructing Nilwala flood protection scheme. There was a natural pyrites deposits in the area which was not identified properly at the planning stage. So once the pumping started as a part of the flood prevention, this deposit became active, and it takes some time to realize the situation to the scientists and make the remedial measures. So salinity is no more problem in Kirillakali sector, but adopting to the new farming practices to overcome this situation is a challenge to the farmers there at the moment. Okay, what are the solutions we can think of? As for any other subject matter, we have structural and non-structural solutions to mitigate the salinity in the water. These are some of the structural measures I can name which are being practiced in our country as well as in all over the world. As the non-structural measures, the government can impose regulations, or else as responsible citizens and corporate sector, we have obligations to impose self-regulations for all our activities. With that note, I would like to conclude my intervention by handing over the stage to the experts to continue. Thank you very much.
Thank you very much, madam. I think you can unshare.
Yeah.
Yeah. Now, From here onwards, actually, we will be starting our lectures. Our next presentation would be conducted by Professor Jayanta Bisekara, Director of the Sea Level Solution Center, Institute of Environment of Florida International University of USA. But before starting the presentation, I'd like to mention a couple of things. From here onwards, you will, the audience will be listening to 4 main presentations. And I would like to invite all of you to listen carefully. And if you have any questions, you can post them in the chat box. Along within the brackets, you can mention to which speaker you are forwarding the question and aiming at. And at the Q&A session, the moderator will take up those questions. Now, let me briefly mention the credentials of the expatriate Sri Lankan professional, Professor Jayanta Bisekara. He is the, as I mentioned, he's the director of the, and research professor in the Sea Level Solution Center, and he has won a number of awards and involved in a number of initiatives in the USA. For example, he served on the Federal Advisory Committee, which directed the development of the National Climate Assessment in 2014 in USA, and he is the 2015 recipient of the Norman Medal of the American Society of Civil Engineers. His research areas are climate change, sea level rise, hydraulic modeling, adaptation and resilience, and water management. Okay, with that brief note of introduction, I would like to direct this presentation and I would like to invite Professor Bisekara. Over to you, sir.
Yes, Ms. Tsunami, can you see my screen?
Yeah, we can see you. Yes.
Is that the full screen or the presenter view?
Full
you can
screen.
See the full screen. Okay, good. Okay. All right. Thank you. I want to thank Professor Senaratna for that introduction and Ms. Engineer Kamala Das for that nice description of the problems and some solutions. And I also want to thank NSF, SLAS, and IESL for inviting me. Without talking too much about me, you know, Ms. Tsunami already introduced me. I will basically focus on the sea level rise and the saltwater intrusion aspects. I believe that that's, as Engineer Kamala Das explained, over 90 watersheds or basins around Sri Lanka are coastal basins, and with sea level rise, the saltwater intrusion is going to be significant. So I will talk about facets of saltwater intrusion and climate change, and also in terms of sea level rise scenarios, what should we expect in the future? I also want to talk about some experience we have in the US for monitoring, modeling, and impact assessment, and some ideas from me, basically some potential solutions and possible pathways. So basically, in terms of climate change impacts and including rising sea levels, you can see this little cartoon in the middle showing an idealized area with coastal urbanized region like Miami, for example. And there are multiple threats due to climate change, primarily sea level rise. You have storm surge impacts, saltwater intrusion, and urban flooding, and also natural system impacts like the Everglades. You see all these pictures around to show some of the impacts that we already have. For example, this is a little video that I took. I guess it is not playing, but in Miami Beach. So I'll go a little bit more into the details of this you know, as I go through my presentation. So initially, basically, I want to give you a basic idea about the saltwater intrusion process. You know, you see a cross section of the ocean and the land itself. You have the fresh water on the land side and seawater on the ocean side. And then you have this zone of dispersion. You basically transition from salt water to fresh water. And ideally, to model or understand this zone of dispersion is somewhat difficult. There's not a whole lot of data. And as I will mention later on, in terms of modeling, we assume this has a sharp interface and try to understand with sea level rise what the saltwater intrusion extent or how the saltwater front might move. This is an example depiction of what could happen under sea level rise. You basically have water supply for residential areas or urban areas. And with pumping, you basically have what is known as upconing, basically a saltwater front being drawn into the well and basically salinizing the water supply for that community. And to the left, you will see the irrigation wells that are also typically, you will have fresh water, but as the saltwater front is moving, that might have salinized the irrigation wells, affecting the agricultural areas. So what are the important factors defining the saltwater intrusion? Basically, you have rainfall recharge, and as we discussed earlier, with climate change, if the rainfall is reducing, recharge will be less, and that will probably induce saltwater intrusion further into the aquifer where you draw water from. That is the flux coming from the regional groundwater flows. And then obviously the head of the water table is also an important factor, and the sea level. So this graphical display or idealized display shows the important parameters, the recharge, the flux, sea level. And then basically we are interested in the saltwater front, which has what we call a saltwater wedge. What happens to this toe as the sea level is rising? And there are a lot of equations for this, for computing this toe. And traditionally, this is coming from over 100 years ago, known as Geibel-Herzberg approximation, basically defined under idealized condition, what is the depth of the saltwater front with respect to mean sea level here. And so if you have a depth of water or head above the mean sea level of H, and your depth to saltwater front is Z, basically is given by this ratio of these two quantities, basically using freshwater density and the saltwater density. And by substituting those numbers, you basically have this equation, simplified equation. Depth of the saltwater front is 40 times the head of the water table above the mean sea level. And that's a convenient way to kind of get an estimate of, if you, for example, have 1 foot of head above mean sea level for groundwater, basically your saltwater front is like 40 feet below. So this is some of the earliest ways of describing the saltwater intrusion process. Another important aspect in the coastal areas is, when you have naturally environmental sensitive areas, particularly around Sri Lanka, for example, you have mangrove zones or marsh areas. With sea level rise, these marsh areas will be basically converting the salinity regime in those, and naturally they will basically move upstream, or what we call marsh migration, and might impact adjacent land agricultural areas. So this is another example what could happen in environmental sensitive areas. Yes?
Excuse me, this is Banduni. There's a small technical issue due to the number of participants. Therefore, ISL requests us to stop this for 3 minutes and rejoin with the same link once again, because they have given us 100 participants, but there are around 200 participants registered by now. So there are a number of people who are out from this session, and therefore I request all of you, the participants, to re-log in within 3 minutes. Thank you very much. Sorry for these inconveniences. Thank you. So this will stop for a while, and then please re-log in again. Thank you. Sorry, sir.
So do I need to re-log in as well?
Yes, sir, all of us, everybody, because they will increase the participant number to a different one, and then we have to re-log in.
Is that the same link?
Same link, yes. We have to use the same link.
Okay.
Sorry for all the inconveniences.
So I think after reaching the previous level, number of participants, shall we start? I mean, by around 100.
Yeah, I'm ready. Let me
We'll
know
wait
when
a
to.
little bit. We'll wait a little bit for some more to join, like 100. Then others could eventually join. Yeah.
Okay.
So can we start from the theoretical background of salinity intrusion? I think most will not be able to join by time.
Oh, you mean start going back to
Few slides,
okay.
yes, sir. Sorry for that.
It's okay. Yeah.
The problem has rectified already. Tirina, we can go ahead.
Okay. So, Professor Jayanta Bisekara, sir, now he will continue. I think you are starting from the beginning.
And no, I'll go to the maybe the starting from the like the fourth slide. I think.
Okay.
Do you want me to start from the beginning? I don't mind. Either way, it's fine. What do you think?
Don't mind, so we always like to listen to you. It's better to start from the beginning because.
Yeah. Okay.
Thank
All
you,
right.
sir.
Okay. Thank you.
Sir.
No problem. Can you see my screen? Let me see. Can you see the screen?
Yes.
Yeah, the full screen, right?
Yeah.
Okay. Good. Again, good morning, everyone. Sorry about the technical difficulties. It's always happened. You know, you don't get a good estimate of the number, and technology always sometimes fails us. But it got corrected pretty fast. So today I'll talk about the facets of saltwater intrusion and climate change. I will focus more on the sea level rise. You know, I think Engineer Kamaladas mentioned there are 90 some coastal basins. They will be significantly affected by sea level rise and saltwater intrusion, and I want to give you some general idea about what are different ways of that saltwater intrusion could affect the inland areas. And then I will talk about rising sea level. What do we expect around Sri Lanka? And the importance of monitoring, modeling, and impact assessment. I think monitoring is an important aspect I want to talk about, and potential solutions and possible pathways. This is a little cartoon diagram of, what ways the saltwater intrusion and sea level rise and tidal and storm surge impacts could be affecting mixed use landscape, in this case, heavily urbanized area and some natural areas and agriculture. And you see all these pictures, these are actual pictures. This particular video is from Miami Beach. I actually took that. It's called Sunny Day Flooding. There is no rain, but the streets are flooded basically from tides coming into the streets. We'll talk more about that. So I think it's good to start on the cross-sectional view of how the saltwater intrusion process happened. The heavier salt water is intruding, depending on the sea level, into the freshwater aquifers. Basically, the zone between the freshwater and saltwater is called zone of dispersion. This is a tough one to model and monitor, and a lot of times we assume it's a sharp interface, but we are very interested in knowing, as the sea level is changing, how this zone of dispersion or the saltwater wedge moves inland. And this is an example of how it could affect the water supply, not only for residential areas, but also for irrigation wells for agriculture. As the saltwater wedge is moving inland, if you have a well for residential water supply, there would be what we call upconing, basically saltwater being drawn into the wells. And if the saltwater wedges moves closer to the irrigation well, that will also bring saltwater into the agricultural areas. What are the factors that are important? Basically, there are several factors that are important in understanding the saltwater intrusion process. Flux coming from the regional groundwater system, the recharge from rainfall, for example, again, with respect to climate change, this is an important aspect depending on the rainfall changes, sea level rise. And another aspect of important to us is the saltwater wedge. There is a place what we call a toe of the wedge, and typically we're interested in knowing how the toe would move inland as the sea is rising. And about 100 years ago, this very simplified expression known as Gibbon-Herzberg approximation was developed, basically to define the depth of saltwater front with respect to mean sea level rise and relate that to the head above the mean sea level. This is the freshwater head. And you have this nice relationship as a function of freshwater density, rho f, and saltwater density. And when you plug in the numbers, you get this C equal to 40 times H. And this is a very convenient way to know, for example, if you are 40 feet below the mean sea level. And so that's a kind of an early development of saltwater intrusion process modeling and modeling, basically using analytical techniques. Another area of interest is to us is this natural marsh areas along the coastline. As you can see, as the sea is rising, the tidal flooding will basically change the character of these marsh areas and will result in what is known as marsh migration. And if it migrates more towards agricultural areas, sometimes it may be good, and sometimes it might basically take over the agricultural areas. And this example you see on the left-hand side, it's a picture of the Everglades in Florida, for example. Basically, as the saltwater is coming in, this organic peat basically will interact with that salty water and will cause what is known as peat collapse. Basically, the organic soil will collapse, basically meaning all these mangrove zones will move up, or the land elevation itself will change. So there are important aspects of saltwater intrusion process and the sea level rise in general. There are what we call compounding effects or compounding threats. Why are they compounding? What are these compounding factors? Obviously, sea level rise is a compounding factor, but with sea level rise under climate change, you may have increased frequency of storms, tides, and waves. And under climate change, your precipitation patterns may also change. And then obviously the river discharge coming from upstream parts of the watershed might also change with rainfall changes. And this is a little graphic from Google Earth I took. I built some area in Sri Lanka. And the basic problem here is basically an open connection to the ocean through these rivers and canals and waterways, and many of them don't have a salinity barrier, as we discussed. And that's a conduit or pathway for saltwater to migrate upstream and create all kinds of saltwater intrusion problems. So when we look at this sea level rise and climate change, we talk about what we call stresses and shocks. The stresses are slow moving drivers. For example, rising sea level is a stress. Or reduced precipitation might be a stress, or reduced river discharge. Coastal storms and hurricane and cyclones are basically what we call shocks. And basically a tsunami is a shock. I will show you some example of what was done in the 2004 tsunami. So there are four typical impacts that we should be thinking about. One is the surface flooding of salt water, like what happened in a tsunami. And the other one is groundwater flooding, and I will explain that in a minute, in the next slide. And saltwater intrusion below ground that we talked about affecting well fields and others, and the saltwater intrusion in open rivers, basically like the example shown here. So basically you have this compounding effects of multiple factors associated with climate change that typically you can't just look at saltwater rising sea level by itself. So this graphic shows what happens with rising sea level. Basically, this is the water table in here, and one thing that is very important to understand is that the saltwater sea level rise will basically push the water table up. So water table rise, and depending on low-lying area, whether you have a low-lying area or not, that will cause some what we call groundwater inundation or groundwater flooding. And the other aspect is as the water table is coming up, there is not enough soil storage to absorb rainwater. That itself may cause more runoff and cause flooding. And the other aspect, obviously, the saltwater intrusion front moving inland. So as I mentioned earlier, another aspect of saltwater intrusion is this open rivers or waterways with open connection and having saltwater front moving up. I think earlier Engineer Kamala basically explained what happened in Kalani River and some of the other rivers with sand mining. The saltwater front movement is exacerbating, and that itself is a problem. So a classic case of shocks is the tsunami in 2004. I happened to visit this area right after that with the actually US NSF team. This area, you see all these wells that are in residential areas which were completely destroyed. And it was interesting to find out or develop this conceptual model of what happened during a tsunami or even a cyclone flooding. Basically, you have this heavier salt water on top of fresh water. And theoretically, that's what we call an unstable problem because you have a heavier salt water, and I will talk about that in a minute. So you have the traditional saltwater front, but in this case, you have a saltwater flooding, that saltwater infiltrating into the ground. This was researched by Dr. Methika Vittanage. She had actually some nice, interesting work done, not only field monitoring, but also modeling and some experimental work in a lab. In this case, she had a transect of 20 pisometers in an area that was actually during wartime was pretty tough. And she had collected enough data to do the modeling and assess how long it will take for effect of tsunami floodwater to basically cleansing the freshwater resources they have. And there are a couple of papers that were published. So in this case, the real problem was there are a lot of wells that were basically contaminated with salt water. The question was, how long will it take for the wells to be cleansed? And so there was this experimental setup to understand the saltwater flooding on top of fresh water. And one interesting theoretical aspect, some of you who may be interested in this particular type of problem, you have this instability, and that causes what is known as fingering. And this is very, very difficult to model because numerical errors appear as fingers, but in reality, there is a fingering going on because of that instability. So there was this experimental work that was done at University of Colorado, and also did some modeling. She did some modeling understanding with recharge, with saltwater intrusion, how will this saltwater flooding will basically dissipate with time. And her conclusions were simulations show that rapid decrease of salinity initially. It also showed that the plume migration depends on the heterogeneity of the aquifer, but more importantly, it showed that it may take 5 years to, for the freshwater the groundwater to be cleansed, after this event. Probably nobody went back and checked it, but that was the important finding in that study. We also looked at the climate change in terms of rainfall and temperature. You all know rainfall. I think Professor Senaratne mentioned that it's very important for recharge in many areas of the country. With Navendra Kumar, who is in actually University of Jaffna in Kilinochchi campus, we did some studies to understand what are the trends in rainfall. And some interesting findings were that you have actually reduction in May rainfall, this blue circle showing negative trends. And in Southwest monsoon season, basically there was an increase in extremes. So these were kind of an important findings for future, how the climate change might impact the recharge and rainfall runoff processes. Another important aspect that you all know, that warming is already happening in Sri Lanka, in every part of the country. This shows the rate of increasing temperature. It's about on the average 0.15 degree per decade, every part of the country. And obviously, the higher the temperature, higher the evapotranspiration, the losses from the water, basically. So you have net recharge into the groundwater could be less in the future, and that could itself affect the salinization. So there was an interesting study of the global vulnerability of sea level rise. So there are, you see on this left graphic, there are two types of saltwater intrusion happening. One is what is known as recharge control system. And these are typically in highly mountainous or more arid regions. So basic idea is the topography is high enough that as the saltwater is pushing the fresh water up, there is space for the fresh water to go up, basically to be pushed up. And that itself will help maintain that gradient, keeping the saltwater intrusion, a little bit with a lesser impact as compared to this other scenario called topographic control system. Basically, these are low topographic areas, humid. And what happens is that the saltwater is pushing the fresh water up. Because of the low topography, you have that groundwater flooding, and there is no space for that pushed up freshwater table to go up. And that means you have more and more saltwater intrusion happening in those kinds of cases. So in this study, they looked at all around the globe. About 70% of the coastlines are topography limited. In other words, you have topographic control systems, and you can see even in Sri Lanka, it's a topographic, control system. Particularly, you have a lot of low-lying areas around the country. So what are the impacts? And these are some pictures of what's happening actually in Florida. We see this overflow during even king tides or high tide, typically in October. Basically, saltwater moving inland into land, basically lawns and people's yards. It's also seepage, across seawalls, water bubbling up. It's disrupting the transportation significantly, inundating the natural areas like the Everglades. Groundwater table is rising, and obviously the storm surge impact. So these are typical impacts that you will see more and more of these in the future as the sea level is rising. Another aspect that's probably relevant to Sri Lanka is, you have these coastal river systems, and in this case, coastal canal systems. And these were built in the 1950s or so. And they realized if they enlarge these canals for water supply, the saltwater would come inland. And they built at the end of this canal, this what we call saltwater barriers or salinity barriers. And this is one of these things you see. These are gravity structures that are basically have gates. They have gates basically to open during interior flooding or rain events to let water out. But now we are finding that with sea level rise, those gates cannot be opened because the ocean side is higher than the inland side. And I'm sure this is happening over there as well in areas where you don't have any salinity barriers. So now people are beginning to put major pump stations to pump out water because the gravity structures cannot be operated. Another significant impact is, obviously, similar to Sri Lanka, you have a lot of wells. In your case, probably a lot of dug wells, but in this case, Florida, you have a lot of well fields where pretty much all the water supply for potable water use come from these well fields. And this red line is basically where the saltwater front is. And you can see how close the wells are to the saltwater front. And I think like the earlier we talked about Jaffna and Kalpiti area where you have a lot of karst areas. This is like the rock we have in for example, in Florida. It's basically like Swiss cheese. You can't build the dikes along the coastline like the Dutch would do because the salt water would come underground underneath. And basically this is what's happening. This basically, the saltwater wedge will come and contaminate the well fields. So this is a historical image. These are historical images of how the saltwater front has moved inland, and this is what could happen to any area with sea level rise. This is in 1904 all the way to 1995. You can see gradually it's moving inland, more so through the canals. Which are open to the ocean. The other aspect of saltwater intrusion and sea level rise is what happens to on-site septic systems. And I think we have many areas have on-site septic systems. In developed countries, there's no difference. They also have on-site septic systems. So basically, as the water table is rising, the groundwater will basically interact with the septic tanks. And I don't know how many places in Sri Lanka have drain fields, but basically these systems will start failing and the groundwater will be contaminated by the septic tanks, and all this groundwater will eventually end up in environmentally sensitive water bodies like lagoons and estuaries. And this is what happens. You have septic tanks that are vulnerable or compromised or failed. And if they're high enough, they might not be vulnerable. And there is an intense effort to basically connect these on-site septic systems along the coastline to regional sewer systems. So all that contaminated water will not end up in this natural water bodies like Biscayne Bay in this case. So I've looked at the sea level rise rates around Sri Lanka for this talk. There are a couple of sites you can get the sea level data. I know the Coast Conservation or NARA probably have the data. So unfortunately, the data from some of these sites in India are not long enough. So I wanted to see what is the rate of rise around Sri Lanka. And basically, there is a long record in Mali, which I think would be a good record to understand what the regional rate might be. You can see there's an increasing trend since about 1990 in sea level rise, which I'm sure is being felt all around Sri Lanka. And if you compute the rate of rise, it's about 4.5 millimeters per year for the mean sea level, which is actually greater than the global average, which is about 3 millimeters per year for the same period. And I will explain why this could be higher. And more importantly, the maximum sea level also has a similar trend. And that's important for that storm surge flooding I mentioned earlier. So the question is, what could be the sea level in the 2030, 2050 or future? And basically you need this to plan your adaptation strategies or measures that you want to take. So let me explain that a little very quickly. And I was involved in these studies that predicted the global mean sea level or the regional mean sea level for the US in several studies. So there are two reasons why the global mean sea level will increase. One is it's like a bathtub. You either add water or water basically is heated up due to absorption of heat from the global warming phenomenon. So you either water expands or you add water. Where is that water coming from? They could come from the land-based ice sheets like glaciers or Greenland and Antarctica. And also it could come from the land water storage. Basically, when you pump or let water out of reservoirs and others, that sea water or ocean is like a bathtub. You get all that water. But there's a lot of uncertainty in this ice sheet melting. The models are not very good in predicting this. This is why there are a lot of there is a lot of uncertainty in the sea level rise projections at the global scale. Then there are other phenomena that happens at the regional scale, like Sri Lanka. There are basically two things I want to talk about. One is as the ice is melting on the ice sheets, they also change the gravitational field around the globe, and that itself changes the sea level. What happens is when the ice sheet is melting, the gravitational attraction it had is no longer there. So the ocean will deform itself to reflect that. And the other aspect is the ocean circulation dynamics. And, in some parts you have these, very large ocean circulation patterns. They itself will change. So the regional sea level will change due to these two. But since we are measuring sea level with respect to land, when the land is subsiding due to pumping or other aspects, soil subsidence, that also will affect the sea level that we measure. So these factors affect what we call regional sea level. And fortunately, before I get into the prediction of that, so when you look at the sea level rise trends all around the globe, it varies from place to place. Some places are higher than normal or higher than zero. Some places are actually basically depleting. For example, near Alaska, for example, the land is uplifting. So that means the sea level is falling. So it's not uniform throughout the globe. So there have been a lot of studies, and I was part of this study as well for the US. So there, because of that uncertainty, there have been several scenarios predicted on the climate change phenomena into the future. And this is what we call a scenario approach. These RCPs are the warming scenarios. And this is the planning. These are used for planning in many parts of the country and also around the world now. These types of scenarios. So it could go up to 2.5 meters in the extreme case when all the ice sheets might be melting at a much faster rate. This is the 2100, and you can imagine 2.5 meters is quite a lot, particularly for low-lying areas. So, there is a whole philosophy on how to use these scenarios based on the risk of failure of your projects. Some probabilities associated with that could be used. But then again, I used this information and, I was in touch with the people who developed these regional scenarios, and there is a gridded projection set for all around the globe because, we were involved in predicting sea level all around at all the military installations for US. And so for that, they had to develop basically gridded set of sea level projections. So for this talk, I picked up all the grids around Sri Lanka. There are like 5 grid cells. And I plotted the sea level rise projections for these 5 cells. One important thing is there is not a whole lot of difference around these 5 cells. You can see these lines are very close to each other. And this purple or color, or whatever this color is, this is the global sea level curve. And then these other tightly packed curves are the regional sea level curves around Sri Lanka. So you can see at 95th percentile, they are much higher than the global. And this would be very useful for planning purposes. If you are, let's say, planning a project up to 2080, you can use this number of, let's say, 100, 120 centimeters for planning purposes, for projects around Sri Lanka. And I think this type of, data would be very useful. This is an example that I think Bandula Vikramarachi, Professor Banduni shared this with me. He had done a nice study, basically using those sea level rise scenarios. If you have a good digital elevation model, you can do a vulnerability assessment. For example, in the US, we have a similar tool where people can go and play with the sea level rise, and they can even zoom into their street address to see what would be the threat of sea level rise into their, and that's the kind of tool that would be useful. Really, we need the good digital elevation data for the coastline. And I think he also did some hazard map for sea level rise, even the economic losses due to basically bathtub inundation or inundation just by sea level rise. This is the type of studies I think that is important. A very important aspect I think we need to pay attention to, particularly in Sri Lanka and in other parts of the world, they are already doing it. Like in Florida, we have this example where you have on this left-hand side, this is a coastal county where you have a lot of well fields that you provide water supply. So these are very important water supply wells, and people want to know where's the saltwater front. So what is provided here? What is shown? I think somebody needs to mute. Maybe I can see some noise. You see all these what we call monitoring wells. So there's a series of monitoring wells that are carefully located to basically monitor the salinity at different depths. For example, these are the plots of salinity. You can see in this particular well, it has been fairly fresh until about 2000, and now it's rapidly increasing. Now this rapid increase could be due to inland pumping or sea level rise, but they know that this well field in this particular case needs to be abandoned because you don't want to pump in salt water for potable use, or you have to basically use some kind of desalinization or treatment to treat that. So an important project here is to monitor the saltwater front. This is not the saltwater at the surface. This is like where that saltwater toe is that I mentioned earlier. What is the, at what depth you find that that saltwater that's not, the fresh water that's not suitable for drinking purposes because of the higher salinity. So this monitoring is something that I emphasize, and I feel like we need to have a monitoring system especially in vulnerable areas around the country. In some cases, in some parts of the, some areas, they use helicopter, kind of what they call a plumb bob or some kind of geophysical mechanics to monitor resistance from saltwater intrusion, and they have been successful in mapping the saltwater front. So this is the product that is produced by them, for every county, every 5 years, the saltwater front is mapped. And this is a very useful indicator of how bad the saltwater intrusion is in the coastal areas. And that way you can see is them moving inland. And one of the things that you can see, these numbers, G34, G54, S30, these are coastal salinity barriers. They're very effective in maintaining the saltwater front. So basically you provide water, enough water to maintain a head behind these structures in these coastal canals or rivers. And that's something I would come back to later on as a measure. So modeling is also important. There are, multiple ways of doing the modeling. There are what we call analytical techniques. In this case, a traditional, you have an ocean on one side and landscape into the interior. There are analytical equations for these. Or the island situation or island strip situation, you have ocean on both sides. And basically, there are analytical equations for that as well. There's a nice book on that if you're interested. The other approach for modeling is groundwater modeling, basically. This is a one-dimensional modeling, basically showing how the saltwater front would be moving. That's a software package from US Geological Survey called Model Muse that you can use, very easy to use. Or the mud flow model with 2 or 3 dimensional modeling. And we did this study in this region where we looked at the sea level rise to see how far the saltwater front would be moving under future conditions to understand what are the mitigation measures we need to implement and what to expect in the future just from the sea level rise and interior pumping. So I'll finish very quickly. I know it took a little bit longer because of the technical difficulties. These are my thoughts on what could be the potential solution. And I think some of these were discussed earlier. Diversify options for water supply and expand sources. And cheapest water is the water you don't use. So water conservation is an important practice we need to think about. Implement saltwater intrusion barriers. I think we saw that, some cases of that in Sri Lanka and here, both surface and subsurface. Potable water supply, we may have to increase treatment or desalinization, for example. Install low-head dams or saltwater wedge to maintain, separate the freshwater pool. And more importantly, maintain efficient drainage pathways. I think that was discussed earlier when your open river is connected to the interior area, agricultural areas with drainage. And if the drainage is not clear, it's not going to drain and water would back up into the agricultural field. And an important aspect I would think is the monitoring of the position of the saltwater front. And I think this is where we need a monitoring system. Research and implement salt-tolerant crops, soil treatments, and others. And I'm sure the other expert who know more about this, and we'll talk about that in a few minutes, very soon. And assess and adapt to future condition. In other words, plan for the future condition. That's why the modeling and monitoring is very important. Couple of examples. In this case, this is a farm right next to a brackish ditch. And this is probably not a good idea, but here, the same example, you have what is known as basically a riparian buffer between the agriculture area and that buffer, the ditch. One last few examples. In California, for example, they actually have a lot of pumping going on. The saltwater front has been moving in. So they actually have basically a freshwater barrier through an injection well. The downside of this is you need a lot of water to maintain that barrier, but they practice this now so they can maintain the saltwater front from coming in. So that's one example in Southern California. One in Florida, and this is an important one, I would think, for Sri Lanka as well. In areas where you have an open river connection, and in this particular case, there's a water supply intake for cities. So this large lake provides water certain times of the dry periods to push the salt water back, because the intake would be, otherwise intake would be salinized. So having, let's say, a water storage upstream or having a reservation in the upstream reservoirs for saltwater management might be a solution that needs to be thought about. And in California also, they have this Bay Delta system. The salinity is important for the fish. they have what is known as X2. That means the position of the saltwater front where you have 2 parts per thousand. So they monitor that every year, and they release water from upstream to maintain that X2 at the right position. They also have salinity barriers as well. So this is my last slide. What are the possible pathways? I think we need to recognize coastal belt as a very sensitive area, what we call an adaptation action area, and basically having some policies to manage the land use in these areas to mitigate the sea level rise impacts. Identify saltwater intrusion high priority areas, and basically develop short-term and long-term adaptation portfolio. And I think earlier we heard structural and non-structural options. Policies would be non-structural basically. I think it's in the wrong place here. And importantly, develop a network of saltwater intrusion monitoring, a national network. You can start with the high priority areas. And a couple of other aspects of what we need to do, I think, is research and investigation to characterize the coastal hydrogeology, because without that you couldn't do any modeling. And finally, develop a modeling program, at least from a sea level rise point of view. I think these are some of the things that I thought we should consider. And with that, I will stop my talk here. Okay, I stopped sharing.
Okay. Thank you very much, Professor Jayanta Bisekara, for that valuable information. Next, we would move on to the next presentation on role of the Irrigation Department for controlling and mitigation of the saltwater intrusion. This will be conducted by Engineer B.A.K. Chandralatha, supported by Engineer A.D. Suhajni Gunawardana. If I briefly mention the credentials, Engineer B.A.K. Chandralatha graduated from the University of Moratuwa with BSc in Civil Engineering, and she has a lot of experience as a Deputy Director and Director for more than 8 years in the Department of Irrigation. And also, currently, actually, she has a master's in technology in irrigation and water management from the Indian Institute of Technology, and she is the Director Irrigation, Research Support, Process Improvement and Training of the Irrigation Department at the moment. And Engineer Suhajni Gunawardana, he has graduated from the University of Peradeniya in Civil Engineering, and she has been a divisional irrigation engineer in Colombo in 2016, and she's a chartered engineer. Currently, she is working as the Chief Engineer, Project Planning and Design of the Irrigation Department. So I would like to now invite Engineer B.A.K. Chandralatha to deliver her presentation. Thank you.
Thank you, Telina. Good morning to you all. I am Kanti from Irrigation Department, and I would like to present on role of the Irrigation Department for controlling and mitigation of saltwater intrusion together with Engineer Suhajini. Role of the Irrigation Department is to find ways and means of preventing saltwater coming into the land. Therefore, over the years, Irrigation Department has developed saltwater exclusion structures at the channel mouth. Then there are two ways of saltwater intrusion. Professor Obesekara and Engineer Kamala Dasamenan explain most of the things here. I would like to only refresh the knowledge of students who are join with us. I am not going to detail with this method. The saltwater intrusion is the movement of saline water into freshwater aquifer, which can lead to groundwater quality degradation, including drinking water sources and other consequences such as negative effects on cultivation. This is also explained by Madam Kamala Dasa. And saltwater intrusion along the river or drainage channels, which provides a path for saltwater to move inland. I want to highlight this, that this is a natural process. Actually, and this is beyond our control. We shall look at this diagram. This shows that movement of saline water into freshwater aquifer. There are 6 types of aquifers in Sri Lanka. The first one is shallow karstic aquifer of Jaffna Peninsula. You can see here that it is only the Jaffna Peninsula. Other aquifer is distributed over the country. Then I selected this diagram from Dr. Panebokke to give better understanding of how we distribute the distribution of shallow and deep groundwater abstraction points used for urban, rural, industrial zone and water supply scheme. This is also I took from Engineer S. Arumugam. This also explains nicely that how cone of depression is formed and how saltwater is included in the freshwater. Water quality survey in Jaffna. That is also from Dr. Panebokke. I will here take especially that Vadamarachi Lagoon and Uppuaru Lagoon. I want to explain later why we take these 2 lagoons. You can see the electrical conductivity and salinity is the factors he considered with both lagoon. Vadamarachi give the better results than Uppuaru Lagoon. Then cause and overcoming of saltwater intrusion. Causes are over exploitation, pumping, rising of sea level. I am not going to detail with the previous 2 presentations, used more and more detail on this topic. I will keep our time to explain with the examples and with the solution, to explain the solution that overcome also groundwater recharging, natural and irrigation. When irrigating the field in the tilling stage and land preparation stage, we put the water, more water to the paddy field, then the water are seeped to the groundwater and it reduce the salinity. Now Engineer Sohagini will continue with the examples and solutions.
Thank you, Madam. Actually, I am continuing from where Engineer Kanti stopped the presentation. We were mainly looking at two ways of salt intrusion. The first one is affecting aquifers, and the second one is saltwater intrusion through rivers. So let me just spend about 2 minutes to show you about one of our projects, ongoing project, that we are trying to give salinity-free water for Jaffna Peninsula. This is actually, you can see Padamarachi Lagoon here, which has 78 square kilometers in area. And what we are going to do is, we get about 20% of water from Padamarachi Lagoon, and then store this water in a different place, making a pond with the square kilometer of 6 in area. Actually, this is a proven proposal to harvest clean water from Padamarachi Lagoon. There were many researchers carried out regarding this one. 12 PhD students from University of Surrey from 1999 to 2011, funded by WHO, have carried out researches. If I talk about main features of the project, Jaffna, we get rain mainly on October, November, and December. That is from northeast monsoon. And what we are going to do is, we first let October rains to flush out the salt in the Padamarachi Lagoon, and then we let collect November to January water in the Padamarachi Lagoon, and at the same time we send the upper part of the water. So once the salt water gets settled on the lagoon, the upper part will be sent to another pond, which is constructed close to Uppar Lagoon with 6 square kilometers in area. And then from that pond, we will send this water to water board so that they can treat and use for their network to supply water for drinking. If I tell about some figures, main figures, the pond storage will be 18.25 MCM per year. And we plan to give water supply as 50,000 meter cube per day using this project. And currently in Jaffna, there are about 7 water supply schemes where they get water from wells. And total supply of that is around 5,000 meter cube per day, which is not sufficient to cover the water needs of Jaffna Peninsula. And now, if we move on to the second method of saltwater intrusion, that is saltwater intrusion along rivers or channels. So I think Professor Bisekara mentioned how this the phenomenon of saltwater intrusion through the sea. As everyone knows, there are about 103 river basins in Sri Lanka, and we have faced this salinity problem mainly in wet zone rivers during last 10-20 years. Kalani, Kalu, Nilwala, Ging, Bentara, Irrigation Department and also Water Board have faced many problems in this area. And also Malvatue, recently we have got some problem regarding salinity, and the farmers are not able to cultivate due to the salinity of the soil. Let me explain more about these things in next few minutes. So regarding river management, actually Professor Bisekara touched about the coastal part. What I wanted to emphasize is irrigation department, we are constructing dams across rivers and store water for irrigation and give water for drinking to the National Water Supply and Drainage Board as well. And then Coast Conservation Department is the one who manages the coastal part with tide problems and many other problems due to natural hazards. So sand mining plays a very big role in having salinity in rivers at the moment. Actually, there is an annual production of sand in a river system. So once it is get deposited, it is possible to take them out. Now the problem is earlier in all days, only the local community were doing this mining part, so that once there are some deposits, it is taken away. But now after 1990s especially, sand mining rate, especially in wet zone, is drastically increased due to the needs of construction industry. And as a result, the beds of rivers, many of the bed zone rivers, the beds are under sea level up to certain kilometers from seamount. So therefore, river sand mining must be allowed, because if there are deposits, we can take them away, but it should be with strict rules in the sense regulations and recommendation with the relevant authorities. This is a diagram to show what happens when sand mining is excessive, when sand is taken away. So the bed gets eroded and level gets lower than sea level. So if we look at the other effects as well, as I told earlier, lowering riverbed profile is the main thing. And then due to that, saltwater wedges moves upstream and have that problem. And then river bank collapsing problem we have seen in many places as irrigation department. So this is Kalu River longitudinal section from river mouth to inland. Up to about more than 30 kilometers, the sea is under the sea level. So we have get salinity problem up to this level. So this is Kalani River, again up to around 35 kilometers, maybe more than that now. This is in 2009. So the profile is under sea level. This is again Nilwala River. You can see the bottom one is the river bed at the moment, which is under sea level, and 25 years ago it is not like that. It is just above the sea level. So let's discuss who are the affected people by this saltwater intrusion in rivers. Mainly the water board during dry seasons. They can't take water from their intake due to salinity problem, high level of salinity. So what they propose is salinity barriers. Salinity barriers may be temporary with sandbags or any obstruction, and maybe some permanent structures with gates and some collapsible gates or any other mechanisms with gates. What will happen when they install salinity barriers during floods? What will happen in the upstream for irrigation department as flood operating authority? For us, it is very difficult to manage the flood we can't let the flood goes to the river in time, which cause inundation in upstream. So this we need very good cooperation with Water Board and Irrigation Department in tackling this problem, because we need to tackle the problem with salinity, because everyone needs drinking water. At the same time, we don't want to have floods to inundate people, so we need to get rid of floods as well. So let's see how we have worked so far together to overcome these problems. So I have put some pictures. Kalani actually at the moment still they are having a temporary structure, but after long discussions for many years, now I think detailed designs are being carried out to install a proper permanent structure as a salinity barrier at Ambatale. And in Nilwala, actually at the moment there is an ongoing salinity barrier being constructed. And Ging, in the upper photo, it is Ging River, and they have installed, the Water Board has installed the salinity barrier. And the lower one is again Walaway. They have constructed recently, maybe in 2013, again a salinity barrier. So let me show you a picture just after the floods in 2017 May. Actually, there was a major flood in Kalu River during 2017, and what we had to do is to widen the river mouth to send the flood water quickly to the sea. So as a result of that, when we cut the sandbar formed, we can't do any control over that. So with the velocity of the water, with the high velocity, this widening is excessive. And due to that, after some months, now salinity problem arises. So salinity water comes into the land. So after many dialogues for years with Water Board, now this is the proposal which is under feasibility studies by the Ministry of Irrigation. This is a consultant Tahal proposal which was studied a few years ago, and now we are in the phase of doing feasibility studies on that. The proposal is we will be constructing two groins. That is, we have widened the mouth, so we have some structures here, so the flood water can get out of the mouth easily. We don't need to do any cutting during floods, after floods. And as a result of this widening, there may be salt intrusion. To compensate that, we will build salinity barrier close to river, but upstream to the mouth, so that Water Board people also can solve their problem, and for us also, we think we will be able to handle floods. So this is again one problem we faced last year. This is in Trincomalee. This is in Verugal Aru. This is just downstream to Mavil Aru. Last year, the Water Board was not able to pump water due to salinity problem, and what they suggested was to build a weir across that at the same place. But for us, it's a barrier for floods. So after long discussions with the Water Board and Irrigation Department, the Director of Irrigation Trincomalee, now they have come up to a solution to make this weir little bit upstream, so that we don't get any flood problems. So now we were talking about mainly on drinking water problems. Now let's move on to what we have in irrigation department. At the estuary, the bed profile drops below sea level, as I explained earlier, and as a result, the land adjoining the waterway will be inundated with salt water. The area goes under salt water, get increased with high tide. Being a country which depends on mainly paddy cultivation for support, has to find ways for using the entire land for paddy cultivation. So this is a gated structure where we have installed like 30 years ago to operate, to stop saltwater coming inside. So I will show you our big scheme in Bentara. So this is the Bentara basin, which is between close to Kalu River, and then this is Bentara Ganga, and here LB schemes. This is RB, this is left bank schemes, and this is right bank schemes. So we have everywhere these canals come in, we have small gates installed, so that if we want, we can close the gates and stop salinity coming in, so that these paddy fields are secure with salt water. So these are the data. So salt water bunds in RB, we have done 32 kilometers of bunds, gated structures 52, and also canal network. Actually, this project was initiated in 2015. Earlier we had the system, but it was not up to operating conditions. So again, we have created the project in 2015 to restore these things, and up to this year, end of this year, this will be the end of the project. So we hope we will be getting the results that we have expected from this project. It's the same thing, Bentara RV, Nigama and Ittapana. So these are the conditions before starting the project in 2015. The structures were not operating very well. So bunds were not maintained properly. And I would like to grab your attention on one of the creative attachment made by the mechanical engineers of irrigation department to harvest weed. Actually, we know we have a bucket coming with these machines, but when we do dredging, this weeding, what will happen? Small canals, the banks get collapsed with this bucket due to the weight of bucket and the speed of bucket moving and touching the bunds. So now they have some attachment with some holes, so that we don't get any water into that, but we can just grab weeds. I hope now we have given under this project, we have given this type of attachments to a few divisions, and they are under operation. As I told you earlier, this is again for last 30-40 years. There are some of the paddy fields were abandoned, and now we plan to do the cultivation entirely after this project. So let us finally see what would be the control measures for these things. Reduce over-exploitation groundwater that disturbs the freshwater aquifer. Let them be recharged naturally over time. I think we need to have some policy on this. At the moment, we don't have anything on that. And sand mining, actually there are relevant authorities, but still excessive mining is carried out, although we give permits. Actually, irrigation department, we do recommendation to give sand permits, but somehow we can see there are problems in these things. And the other thing, saltwater barriers, we can't get rid of those, but we need to have proper levels and structures in order to have in order to avoid negative effects on flood because of constructing these barriers. Another thing, actually, if we can, for the areas with salt water, especially the lagoons, if we can send some fresh water from some other catchment to flush those things, it is again will be another solution. The other thing is awareness of people about these problems. At least the school children and the public people, they will tend to think about these problems rather than just putting rules and regulations all the time. Another trend now at the moment, sand mining from inland is carried out, and these holes are filled with soil, and due to this, I think recharging of aquifer is not very well done if you do these things in long term. Because of that, there should be some policies to handle this problem as well. And actually, as civil engineers, we have a challenge. We can't stop getting sand because we need sand for our construction, not only irrigation structures, but buildings, bridges, and everything. But water is the main thing, drinking and as a food as well. So as irrigation department, we need to conserve our river system. We need to think about the sustainability of river system. At the same time, as civil engineers and scientists, we need to find some different ways to be used as construction material. That's a challenge which face all of us today. Actually, with that, I conclude our lecture, and I would like to thank the organizers for giving us the opportunity to present our experiences with you. Thank you very much again for your attention.
Yeah, thank you very much for the presenters for this informative presentation. And as the next presentation, Dr. Jayanta Senanayaka, Director of the Rice Research and Development Institute, Batalegoda, will be presenting the status of crop development targeting saline areas in Sri Lanka. So if I briefly mention the credentials of Dr. Jayanta Senanayaka, he possesses over 27 years of research experience in rice and field crops in the Department of Agriculture. And presently, he is working as the principal scientist in biotechnology of the Department of Agriculture and as the acting director of Rice Research and Development Institute, Batalegoda. He possesses his BSc in agriculture from the University of Peradeniya, MSc and PhDs in the Agricultural Research Institute, Indian Agricultural Research Institute of India. He has over 40 publications on biotechnology, virology, and plant breeding aspects in international and national journals, and he is currently the chairperson of the National Biotechnology Committee. So within that introduction, I would like to invite Dr. Jayanta Senanayaka to deliver his presentation. Over to you, sir.
I think you can hear me and you can see me.
Yeah.
Okay. Good morning. So this is a different aspect when compared to the previous presentations because they were from engineering side. So I'll be talking about biological sides. So present the status of crop development targeting saline areas in Sri Lanka. So for agriculture, we have major climatic zones. These three zones are important. As you know that wet zone, intermediate zone, and dry zone. It depends on the rainfall which we receive. Annual rainfall varies between 950 millimeter to 5,500 millimeter with an average of 1,861 millimeter. And we have a couple of major biotic stresses in crop production. They are drought, floods, salinity, iron toxicity. Out of these, we will be concentrating on salinity. Soil salinity and crop production. Salinity on soil, as you know, it is measured by EC in saturated soil solution, a major problem associated with irrigated agriculture worldwide. Soil salinity creates lots of problems when soluble salt concentration in the root zone exceeds a certain level. In irrigated areas, mostly these salts are originated from salts in the applied water, shallow groundwater. Soil salinity can be defined as the presence of excess amounts of salts like sodium, magnesium, calcium, potassium, chloride, sulfate, bicarbonate, nitrate, carbonate, like that in the soil solution according to a few definitions. Salinity in crop production, we face two threats from salinity. One is due to seawater intrusion as described by previous presenters, and second one is inland salinity. Both are reported to be increasing. Even when in the previous time, even 10 to 20 years ago also, authors were mentioning that these areas were getting increased. Coastal salinity is mostly caused by chloride and sulfate of potassium, sodium and magnesium, while inland salinity is caused by bicarbonate, carbonate, calcium, magnesium and sodium, etc. As I mentioned, crop yields drop when a threshold EC of soil water extract is reached. Salts in the soil solution impact on plants. They will reduce evapotranspiration by making soil water less available for plant root extraction. As a result, the plant may suffer some growth difficulties. Some salts cause toxic effects in plants and can reduce plant metabolism and growth. Saline conditions may change germination ability of crops and varieties. We must remember that the same variety may behave in different ways in case of germination, and some crops may behave in different ways in salt-affected areas. Salinity may affect seed germination in two ways: osmotically by decreasing the amount of water taken up by seeds, ionically by facilitating the uptake of ions in excess amounts, which may be harmful for the embryonic activities. Soil salinity, you know this, I'm just showing this to you according to Brown et al. In 1954. Beyond 8, it is, in fact, it's very saline. Most of the crops can't grow, but we find some places which are reported to be above 8 decibel per square meter. And so, no, generally, rice grows very well between, below 4. Salt affected areas in Sri Lanka. I got this information from Mr. Sirsen, who worked on this aspect much. And these are the coastal salinity area. This data from 2012, but it is valid. And coastal salinity areas, most of the districts are Mana, Putlam, Jaffna, Trincomalee, Ampara like. And then we have inland salinity also, like Anuradhapura, Polonnaruwa, Puslam, Hambantota, and Mana. When we develop crops, so we have to consider both the situations, but these are some of these inland salinity areas are mostly profitable areas like Hambantota and this Polonnaruwa like, the districts which give very high yields in case of rice. But we must remember that there are a couple of crops which have been developed for resistance to chickpea, corn, cotton, millet, sorghum, soybean, sunflower. This is just for your information. I have included them, and I want to say you. But in Sri Lanka, when we try to find information, when we try to find research information, other things, we mostly find that it is related to rice, not for other crops. Rice is the most important crop affected by salinity in Sri Lanka. Why I am telling that? Rice is our staple food, and it is cultivated everywhere in the country, except only a few places like hilly areas, but in all the other cases. So it is more, it has the ability to become vulnerable to salinity. I'm just showing you what has happened with our rice yields, just to get an idea regarding our crop development for salinity. This is rice yields. Gradually it increased. Now we are getting around 4.55 metric tons per hectare, which is among the highest in the South Asian region, according to the newest statistics published by FAO in 2019. But you see how the extent has gone up or down, then how the production has gone up or down. But what I want to tell you, despite the fact that we have salinity, we have achieved something, but to go beyond this point, we need more saline tolerant crops also. So this I'm showing, these are some of the areas where we get inland salinity or coastal salinity. Say for an example, these are I have selected only a couple of districts and I have shown them here. So Anuradhapura, Polonnaruwa, Puttalam, Hamba, Thottolai. So this is how the yield varied within 5 years period. So perhaps these low yields may be due to salinity, may be due to drought, may be due to other pest attacks also. But remember that all these factors contribute equally or more or less to cause less yields or less productivity in these areas. So when you consider Trincomalee, Patticular, Mana, Jaffna districts, it is almost the same. So we are getting around, in most of the cases, we are getting around 4.4 like yield, because in some cases this is due to salinity and due to unproductive land, the less productivity from lands. I'm showing this to you because salinity is always associated with irrigation method. So if we consider the data from 2018 to 19 Maha, this much area was cultivated under major irrigation, 47%, followed by minor schemes, 26%, followed by rain-fed, 27%, followed by 26% rain-fed. In the same way, so we experienced a similar pattern in Yala. It was on the major schemes, it was around 69% and 21% under minor schemes and 10% because during Yala season, whatever the land extent which we cultivate, mostly it is coming under irrigation. So with this irrigation, there is a possibility to experience salinity. That's why I'm showing these two figures to you. Effect of salinity in rice cultivation. Before the development of varieties, I want to show you these things because why I'm concentrating more on rice. Rice is the most possibly affected crop, and we don't have, according to our literature and according to the information which I gathered, which I have, and we have not worked to find other salinity resistant varieties in other crops. That's why I'm confining to rice. The area affected by coastal salinity in Sri Lanka was around 0.112 million hectares in 1972. Why I'm showing this figure, but even it has gone up now. But present cultivated extent is 0.7 million hectares, and during Maha season and Yala 4.5. So the figure which I want to show you here, this is 1/6, almost 1/7 out of this cultivable land area. So it has a huge impact. Paddy soils in inland dry zone areas have become saline due to the insufficient drainage facilities, as our engineers described them. When the evaporation exceeded rainfall in the irrigated paddy fields, these were common. Couple of authors they have provided this information. The salinity problem is reported in a number of irrigated areas in the dry zone of Sri Lanka also. In 1998, couple of decades ago, it was published. It is still valid and it is getting in place. Out of 12,000 hectares of cultivated rice land in Jaffna, about 3,000 hectares of rice lands are unproductive due to salinity. Rajadure in 2003 explained. Soil concentration in the paddy lands of Jaffna fluctuate between soil profile during dry and wet season. Nayak Korala, 1998, reported the development of salinity in some of the agricultural lands of the Mahavali irrigation system, which is providing most of our paddy production to the country. A large extent of rice lands, around 150,000 hectares in the coastal areas and the major irrigation schemes in the island have become low productive due to high salinity conditions in the soil. So if we go any further, large extent of rice land in the coastal area as well as in major irrigation schemes in Sri Lanka have become unproductive due to high salinity. In 2009, Sirsen and Hera explained this, and Gopal Krishnan mentions that during the last 3 decades, around 8,000 hectares of paddy lands were permanently abandoned and groundwater salinity increased by 1.64. Rice is tolerant to salinity during germination, becomes very sensitive during early seedling stage, again tolerant during vegetative growth stage, becomes sensitive during pollination and fertilization, and then becomes increasingly more tolerant at maturity. But interesting thing here, though you find some varieties which are resistant at the germination stage, it doesn't carry the same resistance or same tolerance for salinity in later stage. This is one of the biggest task we are facing in developing rice varieties. Screening of rice cultivars at seed germination and seedling stage is comparatively easier because only short time required. Screening for soil tolerant in the field is difficult as soil saline is dynamic. Say for an example, it can vary spatial and temporal way as salt concentration in the soil. Growing plants in hydroponic can avoid most of such variability. But according to the researchers, when I discuss with them, the biggest problem, though we do it at hydroponics at greenhouse level, but things may vary, and it is very difficult to come to final conclusion regarding varieties when you do different screening methods. Introduction of varieties tolerant salinity is the best solution, as mentioned by Sirisen and Abhay Sirwadhan in 2005. So with this, what I want to highlight here, the paddy is okay below electric conductivity of 4 decisiemens per meter. If EC is between 6 to 10 decisiemens per meter, rice yields can be reduced by 50%. Beyond 10, really it will reduce much. Indica is more tolerant than Japonica. Better sodium excludes, maintain low sodium potassium ratio, etc. Salinity is a complex trait. It involves many genes. Same species behave different to same saline condition in different life stages. This is a very interesting point and the difficult point which we face when we develop varieties. You see, because of the salinity, what we face in it may be uniform, non-uniform plant growth. It may be partial crop loss. It may be complete crop loss or abundant paddy fields, as described by previous presenters. Now we are moving to breeding for soil tolerance. What we do here, we do conventional breeding, we do molecular breeding also. We do pedigree method, modified bulk method like rapid generation advancement like techniques we are going to use. Tissue culture aspects can be used, and anther culture aspects can be used. We use marker selection also. And screening for these things, it is also another arduous task, as I mentioned you. In situ field evaluation, screening of microplots, screening imports, screening solution cultures like that. There are a couple of methods, but they may be successful, they may not be successful in the field when the real situation comes. Rice varietal tolerant to rice. Now I am moving to the development of rice varieties. As I mentioned you that only we have rice data related to this one in the country. Even if you try to find, you can't find other crops which have been developed to tolerate salinity. Tenanak et al. In 2017 identify accession because we have couple of Pokkali accessions because we wanted to identify the Tenanak et al. In 2017 identified 2 accessions. And here Pokkali, I'll explain about the Pokkali at the end of this slide. Then she again identified variety BG406 as highly salt tolerant variety, Pokkali accessions as salt tolerant, BG450 as moderate salt tolerant at the germination stage. She also identified 8402 as highly salinity tolerant and Pokkali accession, BG369 and 8354 as salt tolerant varieties at seedling stage. The variety 8353, BG379-2, BG403, BG406 were identified as moderate salt tolerant at seedling stage. After seedling stage, 4 decisiemens per meter salinity level was identified as the critical salinity level for this strain variety. Traditional rice varieties, Pokkali and non-Abokra, then we have a question. So we are getting most of these resistant genes from Pokkali and non-Abokra. These are originated in the coastal zones of India. Why can't we use these directly? In fact, their plant structures are weak. They are not matching with our requirement and requirement of many other countries. Also, directly we can't use these varieties because they carry very low yields. Because of that, we have to make crosses with varieties which we want to improve, and after that we have to select to understand whether carry the required genes from these varieties. These are called land races found in India. This two-phase model of salt state development in tolerance salinity requires different physiological mechanisms during the 2 phases. Why I am telling that is a very difficult task. These developing varieties and checking them for salt tolerance. Salt tolerance during phase 1 requires tolerance of osmotic pressure, while tolerance during phase 2 requires exclusion of toxic salts, iron from important tissues such as leaves and tolerance. You know that This mechanism takes place in two ways in plants. One is ion explosion, one is osmotic tolerance and tissue tolerance, like that. So these are three different ones. These different physiological mechanisms of salt tolerance during different phases are controlled by different genes, not by one single gene. They are mostly known as QTL, quantity trait loci, the region of genes. They involve in controlling this the mechanism. Interestingly, they may be expressed to different degrees in different genotypes. What it says that when you make the cross with Pokali, when you make a cross with non-Abokra, it doesn't carry the same resistance levels. It may depend, the level of expression to salt tolerance may vary with the genetic background of the original plant. Therefore, varietal screening of rice needs to be carried out separately for the two phases of salt stress development. That's why I mentioned earlier. So if you select plants at the phase 1, it may not work for phase 2 and vice versa. Varieties, genotypes, accessions that are tolerant to osmotic pressure during phase 1 and salt ion toxic during phase 2 can be identified separately, according to Mons et al. As mentioned in 2002. The ideal high-yielding salinity tolerant variety, remember that when we develop varieties, though it carries soil tolerant genes or salt tolerance genes or salt tolerance, it has to be with high yield, and it should be equipped with other resistant characters to pest and disease. Otherwise, they will not be accepted by farmers. High tissue tolerance should be the good, exclude a minimum per day uptake of sodium, high uptake of potassium per day, low chloride uptake, low sodium potassium ratio, good initial vigor, agronomical superior with high yield potential plant type, plus quality grain type. Now people are worrying about grain quality also. So thus we have been the breeders and soil scientists of the rice research institute, including Mr. Sirisena and other scientists. They have been able to develop a couple of varieties under 3 months age class, under 3.5 months age class, under 4 months age class, like that. Because you know that varieties which we develop here, they are coming under either 2.5 months, 3 months, 3.5 months, 4 months, like that. So first one, BG 310, it was a cross between BG 300 and Pokali. Highest yield recorded was 7.5 tons, age was 3.5 months, and salinity tolerance, it could tolerate up to 8 decimals per meter. And it was giving resistance to major pests and diseases also. It was basically cultivated Matale, Anuradhapura, Kurunegala, Puttalam, Mahaveli, and Ratnapura, Hambantara areas. Then another variety which was developed by Mr. Sirisena involved in this very much. 2012 it was released. It's coming under 3.5 month age group. It was crossed between BG94-1 and non-Abokra. Salinity tolerance level, it can tolerate up to 10 decimals per meter. Highest yield recorded was 10.8 metric tons per hectare. Then pericarp color white, brown rice recovery was also good, milling quality like that at that time. And it is cultivated in areas like Anuradhapura, Polonnaruwa, and Trincomalee. Then the RRDI system from Ambalantota, the researchers, Mr. Pathanayak and other researchers, they developed variety 83 and 354. In fact, it is 3.5 months variety. I apologize for the little mistake here. It was a cross between BG94-1 and Pokali with the white pericarp and long medium grain type. It can yield up to 120 bushels per acre, tolerant to saline level up to 8 to 9 decimals. Recommended for salinity affected areas. The demand for the variety is 1.36. There's a big demand in the year of 2020. And Costa et al. In 2020 mentioned that the 8354 showed a greater salt tolerance than that of the standard salt tolerant variety Pokali. Even it was performing better than Pokali accession. Then we had another sister line was from the same cross. This was 8401, but now since it is 4 months variety, it did not become successful in the field. It was also developed in 1992, cross between BG94-1 and Pokali, and it can give up to 6.1 tons per hectare. It was resistant to major pests and diseases like that. And cultivated area Matale, around 5 hectares was cultivated. Why it was failed? You remember that when I discussed with my research team, what they mentioned that we have to develop variety which are resistant to, which are tolerant to salt, but they should have the short age period. Short age period means on the other hand, it gives less seeds. That will be because drought, always salinity is correlated with drought. The variety which we develop for salt tolerant should be able to face the challenge by drought also. That's why it's 4.5 months varieties. Though we develop, though they perform very well in the field, they do not go to farmers. Then, if we consider the farmers' preference, I'm just showing this data. And highest demand for BG310, that's the same story which I told you, because it's a 3.5 months variety. These, but less number of days, but better. But then followed by BG369 and 8354, though it has a very high salt tolerance capacity. Present the recent extent, if we consider BG310, this data is available on the Department of Agriculture's website. National level extent was 5,578 hectares, and you can see this. This was mostly cultivated in Anuradhapura district, followed by Kurunegala, Batik Blower, Puttalam, like that. Then 8354, it was cultivated in 435 hectares during this last 2 seasons, and mostly it was cultivated in Trincomalee, followed by BG369, mostly in Polonnaruwa, and total extent was 150. This is what is happening with our 3 varieties, which are, in fact, we can call as blueprints also, that which have been developed by the Rice Research Institute. Then we have ongoing development program also. We do not leave those varieties alone, and we have ongoing program now at Lapuduwa Research Station. This LD-S2B7, it's a line at the moment. It is the parent is 401, as I mentioned. This Pokkali is there as the parent, which is the salt tolerant variety from India, and we are developing this variety now. It is at the major yield trial stage, and it shows seedling stage up to flowering 7 dcm per meter. And then saline tolerant development Batalakoda also it is taking place. We are getting some samples from on the AFASI project. Ms. Nilmi Ekana and Senanaki is working on that. HN Food and Agriculture Cooperation Initiative. We have got down number of the accessions, but unfortunately these accessions, most of the accessions, they have their life period more than 4 months. So as it is, they definitely will fail in our the development of the, if we release them to the farmers. But we have to make process between them. This is some of the photographs which show which are shown to you about these things which are happening under this project. And these are some of the selected entrance for saline tolerance. These are conducted in Puttalam, Polonnaruwa, and the Batalakoda Research Station itself. Salinity improvement through market selection also, we have started that work. And now progress is, the works are ongoing. Salinity tolerance at different growth stages of life is supposed to be managed by independent genes, as I mentioned you earlier. Characteristics like salt tolerance are controlled by large number of QTLs, which may share homology between genes responsible for other abiotic stressors like temperature, drought, flood, submergence, etc. Salt tolerance is a major quantitative trait loci and was identified in the salt tolerant cultivar Pokkali, which I mentioned to you earlier. It is located on chromosome number 1, and SKC1, another QTL, was identified for Nona Bokra. Saltol QTL confers salinity tolerance at the vegetative stage and explains about 64% to 80% of the phenotypic variation. So it's a good one. And so when people make process, they basically try to work with QTL, these 2 QTL, Saltol and SKC1. Several studies showed that Saltol QTL was detected in some other rice varieties also. Interestingly, it can be found in some other places. Perhaps it may be working perfectly, or it may be they may be defective ones. And we have identified, number of microsatellite markers, which are codominant markers, have been identified to detect these genes. So therefore, it is easy for us to find the presence of these genes when we make process between required parents. These are some of the things which have been done by Ms. Nilmini and team at Batalakoda to develop in developing salinity tolerant varieties using making process, and we are studying about the presence of Saltol QTL and the markers. And this is one of the pictures. So say, for example, this Pokali, you can see the gene is there. The mark is giving the result and like that. And some lines which are being developed, how they are giving results. With these words, but why these varieties are not very much popular in the country? There are a couple of reasons. First thing, we have to identify, we are doing that, identifying the present situation regarding salinity tolerant rice varieties. I want to say that our soil science division, with the EC data, which is covering 1 square kilometer in the country, they are going to develop this map very soon, within 6 months. According to personal communication, they are going to develop and unveil this map within another 6 months. So salinity map for crop cultivation, especially for rice. Collection data from cultivating extent of each salt tolerant variety and land extent affected by salinity. Identifying the problems of the farmers when growing salinity tolerant variety, why they are not becoming popular. We need extension service support. Demonstration field for such varieties in salinity affecting area with the technological packages essential. Identifying the milling problems. You know that sometimes these varieties are not accepted by farmers. This is one of very interesting thing. Though the variety is performing well, though it is giving good yields, but farmers are reluctant to cultivate such varieties because millers don't like to purchase such varieties because they go for certain varieties like Kiri Samba, like already recommended some varieties which have high demand in the market. So once the miller doesn't buy, the farmers, the effort goes in vain. So farmers don't like to cultivate. These are some of the problems which we face. Then promote the self-seed production program is also essential because since there is a less demand, even the government seed farms are not producing much seeds of these from these varieties. Giving technical support for practicing technology package with salinity tolerance activities, continuous improvement to varieties for palatability, milling quality, etc. This is a big task which we face. Now, when we develop varieties, apart from the salinity tolerance, we have to be sure that they carry good palatability and milling quality, etc. Otherwise, definitely they will fail in the field. Salinity management package also, they have been described by many people. Proper land preparation, improvement of drainage condition, addition of organic matter, etc. And silicon application of silicon, role of potassium minimizing negative effects of soil salinity. Then biochar as a solution. The Department of Agriculture has given recommendation application of partially burnt rice husk at the rate of 625 kg per hectare is recommended by the Department of Agriculture for salt affected rice grown soils. And through my personal communication also, people who are like from Mana, they have mentioned that this is a good solution and they have been able to rectify the situation or reclaim, and they have been successful in reclamation of soil. And like that, so we have a couple of practices also we have developed apart from the development of varieties, systematic land preparation, drain canal preparation, organic matter addition, etc. Then old seedling transplanting, because if we try to transplant within 14 to 21 days, they may not be able to bear the salt, the level of in the field. So maintaining water level 2 to 3 until maturity, like that. Couple of things are there. Then reclamation of salt affected soil is a challenge. It's a complexity managing the soil. I think engineers will agree with me. Less availability of good quality water is one of the problems to wash off the accumulated salts. Introduction of salt tolerant rice varieties such as BD 310 is a viable adoption strategy. We still believe that this is the best solution. Integration of cultivation of salt tolerant rice varieties together with implementation of the recommended other reclamation measures would help to attain the full productivity of salinity affected rice grown in soil. Then these are some of the other crops. In some cases, in salinity areas, farmers are growing onion, but yet we don't have salinity tolerant variety. I'm just showing you. Their second crop, we are worrying about coconut. In fact, under salinity conditions, coconut is growing well. I personally also invite that, but we don't have any variety developed to the resist salinity, but instead they have some other problems. They are trying to develop varieties for salinity. Okay, these are my references. And in fact, I should give my thanks to Mr. Sirisena, Principal Agronomist, Ms. Nilmi Senanayaka, Assistant Director of Agriculture Research, Dr. Monica Millevitanachi, Assistant Director Research, Ms. Roshni Havil, Additional Director, Ms. Swarna Herath, Program Assistant of RRDA, Ms. Roshini Madhwanti, Research Assistant RRDA, because all they provided data and information for the preparation of this presentation. Thank you very much. Thank you very much.
Thank you, sir, for that informative presentation and elaborations on different aspects of salinity in crop cultivations. Now, let's move on to the next presentation. It will be on the biotechnological approaches to improve salinity tolerance in crop plants. It will be delivered by Professor Chamari Hettiarachchi, Professor in Molecular Biology and Biochemistry, Department of Chemistry, University of Colombo, and the Chairperson of the General Research Committee of the Sri Lanka Association for the Advancement of Science. If we quickly go through her credentials, she has obtained her BSc in 1996 from the University of Colombo and PhD in Biotechnology and Molecular Biology from ICGEB, India. And she was a postdoctoral fellow at the Department of Cell and Molecular Biology and a visiting scientist at the Department of Biological and Environment Science of the University of Gothenburg, Sweden. And she has more than 40 publications in her peer-reviewed indexed and international journals. And she has received the Sastred Award from UNICEF in 2013. And she has, at present, she is attached to the University of Colombo. And as I mentioned, now it's time for a presentation. Over to you, madam. Thank you.
Thank you, Tilina. Good morning to all of you. So I think it says that my internet is not stable, so I think I better switch off my video. Okay. Yeah, so after listening to several speeches on this irrigation and then how this the climatic changes affects on irrigation, and also the previous speech like it is on these conventional methods so that we have used in Sri Lanka to develop these salinity tolerance crops. So as a last speech, so I'm going to talk to you about these biotechnological approaches to improve salinity tolerance in crop plants. Before I am moving into these biotechnological approaches, I would like to tell you so why we are concerning on these biotechnological approaches. So Sri Lanka is a tropical island in Indian Ocean, so rich with biodiversity and natural resources and with diverse climatic conditions. So it is rich with agricultural history dating back more than 2,500 years. And the primary form of agriculture in Sri Lanka, it is rice production. Not only that, tea, rubber, coconut. So they are also cultivated and are major sources of foreign exchange. So, and also agriculture, it is the key sector in the economy, Sri Lankan economy. And because it is the source of national income, GDP, and source of employment, it's more than 45% that they are depend on agricultural sector. So with more than 70% of the population living in rural areas, depending directly or indirectly on agriculture for their livelihoods, and increasing agricultural productivity, it's a critical step in elevating poverty. And also it is the food source, and there is a demand for industrial use and the international trade. So however, it was noticed like this contribution of this agriculture to Sri Lankan economy, it is being declined. So according to the central bank reports, in 2005, it was 19%, but in 2008, it is 12%, and 2016, it was 7%. So after that, actually, I could not extract those data. And but as I know, so it is less than 7% now. So then we need to look into what are the reasons for this decline. So it may be the limitation of land for cultivation, mainly because of these irrigated lands due to the salinity problem and the climate change. So it's a huge problem, so which leading to different types of natural disasters and extreme weather conditions. And it could be the poor post-harvest practices and also availability of finance and market conditions migration from agriculture to different types of services and industry. So there will be a lead to face the food insecurity, and it is clearly demonstrated the further development and improvement in this area is essential. So there, this modern biotechnology has given a new tool to develop and improve agricultural sector. So now let's see what is this biotechnology. The bio means life, the techno means tools, ology means the use of study or study of. So using biology to create or improve tools, products or processes in agriculture, so we can call as agricultural biotechnology. But this is not only valid in agriculture, for any field of studies. In biotechnology, so there are two main biotechnologies. The conventional biotechnology, it has a long history. So it is from in 6,000, 5,000 years ago. So that technology was evolved. And so then other one is that modern biotechnology. So after invention of this DNA in 1950s, so these modern biotechnology tools were developed in 1970s. So now let's see. So actually Dr. Senanayake has already explained to you these conventional biotechnology approaches to develop the salinity tolerance varieties in Sri Lanka. So I'm not going into details. So mainly it is the plant breeding, because I saw there some questions from the audience. So when he was explaining or giving informations about different varieties, so they're asking whether they are genetically modified. Okay, so it means that so they have some kind of a not accepting. So it may be something like they don't know about it, or then it is like some afraid against the technique. So I don't know somehow. So but here, so I am going to show you how this modern biotechnology is important over this conventional biotechnology. But here, I don't say that conventional biotechnology is not a good tool. Yes, it is. So there are a lot of advantages. Since identify some problems in conventional biotechnology, as it is a slow process to develop new varieties, and when they make the crosses, so they are relatively uncontrolled manner, because we take the DNA from parents and we recombine randomly, and then we get the traits, so which can be recombined with undesirable traits, because we don't know. We do the crossing and we develop the varieties, then those varieties need to be checked, because then it happens randomly. But if something happens, then we need to check and get rid of these unwanted genetic changes. All over that, it is time consuming and the labor intensive. So identifying these problems, this new technology has evolved. It's modern biotechnology. In this modern biotechnology, so the main tool is that it's genetic engineering or recombinant technology. So we can remove the genes from plants, and we can do some modifications and introduce into another plant or another organism. So this genetic engineering techniques, it allows the segment of DNA, so that code genes for a specific characteristic, to be selected and individually recombined in the new organism. And also, so the scientists, they have identified that it allows the quicker development of varieties and involves insertion of only one or few genes to achieve desired characters, allows transfer of genes into crop plants. Their specific characteristic is selected and individually recombined in the new organism. And also, it's relatively precise and predictable, because we know the inserted DNA is known and its function is known. So then this precision and versatility of modern biotechnology enable improvements in food quality and production to take place so more rapidly than when using conventional breeding or conventional biotechnology. So it doesn't mean this is the only technique, only technology. So this has, using this, we can develop the things quicker than conventional biotechnology. So this is to give you some idea about this global status of these biotech crops. So in the highest, you can see in USA. So it's like not only USA, so there are many other countries, even in South Asian countries, that India and Pakistan, Bangladesh, so they all grow these biotech crops. So in this, you can see it is almost all over the world, like in Canada, Australia, Argentina, and the China, it's everywhere, okay? And now, so I hope that you have some idea. So this technology, so there is a value, okay? So there is something to do with this technology. So yes, it's adding value to agriculture. So we can use this technology to increase the crop productivity and also enhance crop protection, improve food quality, and also to improve agricultural, economical, and social sustainability. So to increase the crop productivity, we can do it by improving its yield. So if you want to increase the yield in crops, so usually the crops, they grow outside in environment. So they face both biotic and abiotic stressors. In biotic stressors, that is always affected by the different types of pathogens like bacteria, fungus, and the viruses. In abiotic stressors are the other conditions that we consider as the salinity, drought, flood. But here in Sri Lanka, so we don't have a problem with corn. So in this scenario, so I am going to concentrate with you now only on salinity. How we can develop these crops to face this salinity tolerance. Because if you want to increase the productivity, since there is a problem in irrigated land, so we need to develop some salinity tolerance varieties. So here, this when we want to develop the salinity tolerance varieties, because the extreme soil salinity is one of the most destructive abiotic stress out of those not only here in global agriculture, as it can lead to the degradation of arable soils, particularly those that are heavily irrigated. And it drastically reduces the productivity via adverse impact on seed germination, growth and development, vigor, and the crop yields. And also, let's see how these salinity affects on crop plants. There are many ways. I think some points that Dr. Sena Nayaka has already mentioned. So it induces the water stress, oxidative stress, the nutritional imbalances, iron toxicity, membrane disorganization. It can reduce the cell division, expansion, and also it can disrupt the key metabolic processes and genotoxicity. So because of it can affect in many ways for the plant growth and development, it drastically reduces the crop yield. So when they are affected by salinity. So then the main goal in most of these studies, so they deal with salinity tolerance, is to boost the capacity of crop plants to maintain the growth and productivity. So when they are cultivated on saline soil. So now let's see. So a normal terrestrial plant. So how it impacts the balance this sodium, potassium levels, the salinity. In normal terrestrial plant, as you can see here, as a whole plant, so they take this saline, that the sodium, potassium, and also they recycle in the plant, and so that excludes. And this balance they maintain at tissue levels and also at the organelle levels and also from this, the cell to epidermis, soil to epidermis, and cell to xylem. So you can see in each and every places there are many regulatory molecules, so which regulate this balance, or which regulate this ion uptake, the sodium uptake. So this regulation, it maintains the proper level of salinity, and it fails to regulate these conditions according to the things that I have mentioned earlier, so that it reduces the productivity of the plant. But at the same time, you know, there are some plants which we call halophytes, so which is naturally evolved to face the saline conditions. In Sinhala we call kadalana. So those plants, they are already in saline conditions. It means, so they already have naturally evolved system to face the condition. So either by selecting single molecules which it's maintain the balance or regulation, or by identifying the genes on those halophytes, the key genes and key regulators, we can manipulate those to enhance the salinity tolerance in crop plants. So there are many research that has been done in all over the world. So there are kind of these approaches, so that has been taken to enable the crop production in salinity affected areas, the crop improvement. So first attempts were taken in breeding. So its breeding is perhaps the one of the best strategies to accomplish this goal. So then in the conventional plant breeding methods, so in Sri Lanka still we practice the conventional plant breeding method. So in those breeding methods, it's resulted in significant yield improvement in some crops, so when grown on saline soil, and this resulted in the development of the salinity tolerance crops. But however, the conventional plant breeding approaches, so they are most often, as it was mentioned, it is lengthy, laborious, and are dependent on the access to germplasm with sufficient genetic variability. And for some crops, the genetic engineering strategies, it's provide a viable alternative to conventional plant breeding and are now becoming more widely used throughout the world to produce salt tolerance cultivars. So let's see what are those approaches. So in past few decades, using these genetic engineering approaches, the different types of manipulations were done as a single gene. So single gene means, if you remember, so I have shown you that picture. So there were different types of regulatory molecules. So we can identify one of those as a single gene from diverse range of metabolic pathways. Or we can include compatible solute synthesis pathways. And also we can manipulate this ion homeostasis and antioxidant synthesis, as well as the signaling or the regulatory elements, including transcription factors. But unfortunately, with the limited time, so I don't have time to go in details with all these methods. Yeah, so let's see first how the plant has been genetically modified, or using these biotechnological approaches, the plant has engineered as a single, identify a single gene. So here they manipulate this ion transport or the transporters, because I have shown you this ion transport mechanism is already there inside the plants, even in terrestrial plants. So we can manipulate those transport channels and transporters to obtain salinity tolerance plant. So those transporters or transport can be the membrane transport, because each cell there is a membrane and there are proton pumps, the plasma in the plasma membrane. So there are different types of regulatory elements that was manipulated as the H+ ATPase, and also vacuole membrane H+ ATPase, and the potassium transporters and many more. So I'll show you here. again, so these are those regulatory elements which I have already shown you in the previous picture. So then they have identified those regulatory molecules and manipulate to enhance the salinity tolerance. So here is the evidence. So you can see the large number of research that has been done in all over the world by manipulating the single ion transporter gene. So not only that, it has done as this double or it's 2 or more ion transporter genes manipulating. So this evidence shows that how much research has been conducted. And then secondly, some approaches were taken like this RNAi. Okay, so RNAi is again, so I don't have much time to go in details. So it is a tool that we use to inactivate the genes. Okay, so it's actually targeted, we can targetedly silence a particular gene, and using that approach or strategy, we can improve the crop plants. Okay, so here, like to regulate this expression of this gene by this either overexpressing or by knocking down the specific microRNAs, so which has offered a novel and potentially effective approach to engineer the salinity tolerance. So here against the evidence you can see, so there were the several types of microRNA approaches that has been used to obtain the salinity tolerance varieties in all over the world. And also I mentioned to you halophytes. So halophytes, they already evolved with best salinity tolerance mechanisms. So if we can correctly identify the genes which are involved, so we can transfer those genes into crop plants to obtain salinity tolerance rise. So here, so with that, so and also, so you can see here, so this is the evidence for that type of halophytes were used to transfer genes to terrestrial plants to obtain the salinity tolerance varieties. And already Dr. Senanayaka mentioned this QTL-omics, so that we can use, and even in Sri Lanka, the research has been conducted to obtain the salt tolerance varieties. So I'm not going into details of that. And also, what I want to mention, like these biotechnological approaches that in University of Colombo, so that we conducted some research, but we have not done any kind of field trials. So all this research we stopped at greenhouse level. So that I want to tell at the very beginning. And so one of my PhD students that conducted the research to develop this BG94-1, the drought and against this drought and salinity resistant. So there we have identified that gene from rice only. So here the manipulation we were done. So we identify a best promoter, so which are involving salinity and drought tolerance, and also a transcription factor. The both we have identified from rice only. It's already that is in rice. We have not going to mix up anything else into rice. And then the manipulation was done. So that transcription factor we clone under that promoter, and then we transform into BG94-1. So we successfully obtained these transgenic lines. And then we have conducted this drought and salinity tolerance studies. You can see this transgenic line which shows in this blue bar. So it performs well compared to the wild types. And also we have we measured some phenotypical parameters. So here again, this HVA1, the OSPREB, is that the gene which we have developed and transformed. So that plant, and that is the plant which we have developed against these two conditions, it performed and it survived well under salinity compared to the wild type, it is BG94-1. And also, currently we are conducting some more research. They are at the very preliminary stage. So there again, so we have identified some genes from Arabidopsis, so which has already published that's showing the salinity tolerance. And we identify the same ortholog from Oryza sativa in Sri Lankan varieties using bioinformatics studies. And now we are going to just do some modifications by changing only the promoter of that particular genes to see how they performed under saline conditions. So those are at very preliminary stage, and I don't want to expose that the results that we have obtained since we have not published anything yet. Yeah. So with all that, what I want to tell you, all over the world, the main crop, so that many research has been conducted, as even Dr. Senanayaka mentioned, not only in Sri Lanka, even in the world scenario, it's the rice. Okay, the number one plant that was done many research, even under conventional and modern biotechnology, it's the rice. Not only rice in world, so it has been tested, and some under field trials, the corn, wheat, and canola and soybean. Yeah, so now I want to tell you, so anything, especially in this modern biotechnology, the people are concerned that because there can be a risk. Yes, it is not only in biotechnology, modern biotechnology, any technology, anything, even if you walk on the road, there is a risk. So here also there is a risk. So related to this biotechnology, the risks were identified as this undesired gene flow. So which can make some cross-pollination and create some new varieties as the super weeds. And also it can create some competition with the native species. So it may affect on the biodiversity. Yes, it can. So, but we need to check. And also the new proteins developed by those manipulated genes can make some allergic responses. It is true, but we need to check. And there are some problems with this labeling and labeling issues with different countries under their different regulations and standards. And also there were some reports that there is effects on this non-target animals. But all these are already being overcome by those companies. But however, since there is a risk, we need to test the risk before it released into the for the consumption or to the environment. That is there with this biotechnological research, especially the biosafety is must. But only here in Sri Lanka, still we don't have the set biosafety rules, and it is there actually, but it is not yet approved by the Parliament and all, the Biosafety Act and the rules and regulations. But actually the Ministry of Environment and this FAO and also the National Science Foundation together that we conduct these biosafety projects. Now it is for 3 years. I hope in very near future, so that will be finalized. And so that is the reason. So I told that almost all research that we were conducted, we had to stop at the greenhouse level. Yeah, since there is a risk, even the GM crops which available all over the world, so it is being regulated. So all transgenic crops and their resulting food in USA, they are extensively researched and reviewed by 3 federal government agencies. It's USDA, they check for primary responsibility, so they check whether it is safe to grow. And Environmental Protection Agency, they check potential for impact on environment. Food and Drug Agency, so they're concerned with the protecting the consumer to declare if the product is safe to eat. So if it is past these regulatory bodies, only that will release to the environment. So whatever it's released to the environment, it is safe. So you don't need to worry about. But if it doesn't go through this process, there is a problem because it is not checked. So that is the main barrier here in Sri Lanka, since we don't have this regulatory procedures. Yeah, so not only these, actually these other regulatory agencies also involved with this process. It's World Health Organization, the foundation of these institutes of these food technologies, and the American Medical Association, and this Food and Agriculture Organization of the United Nations. So they are also they established through the extensive research and affirmed by these regulatory agencies as well. So then with all that, so I want to conclude, since Sri Lanka is an agricultural country, so the contribution of this agricultural sector to Sri Lankan GDP is going down year by year due to many reasons. So especially when we concern on this climate change and the salinity issues and all, so we may need to use this technology to develop something and keep aside, not to use, but to keep. Okay, so this, because this biotechnology, it has the potential to improve and improve the production and this food security. So sometimes that as a country, so we may need to change our mindset, so which we have against this GM crops, because this is not to use. I am always telling, so it is just to keep aside, because if something happens, like, you know, now this, we all take this vaccine, so it is also genetically modified one, but there is a need, we take it. So likewise, now then, since we have these conventional breeding programs and since we have these varieties, so we don't want the GM. Oh, it's okay, but there will be a day in future, due to all these climatic changes and all, we need to use that. So in that case, we can't do this overnight. So we need to do it and keep it at safe place. Okay, so here, so there is a say, we can help poor farmers sustainably increase their productivity so they can feed themselves and their families. By doing so, they will contribute to the global food security, but that will happen only if we prioritize agricultural innovation. So it was said by the Bill Gates. Thank you very much.
Thank you very much for that much informative presentation mentioning about different aspects of biotechnological approaches and different bio safety mechanisms. And now let's move on to the next part of our webinar, that is the Q&A session, which will be moderated by Professor Banduni Athapattu. And if I briefly mention her credentials, Professor Banduni Athapattu is a chartered civil engineer who has obtained bachelor's degree from the University of Moratuwa in environmental engineering and PhD from the University of Osaka on environmental engineering. And she was a Commonwealth Fellow of Imperial College London and JSPS Postdoctoral Fellow at Okayama University, SIDA Fellow, University of Stockholm, Sweden. Her specialization is in environmental engineering and she has many publications in peer-reviewed and indexed journals. She is a recipient of several research awards, including Presidential Awards and Open University Research Awards. At present, she is attached to the Department of Civil Engineering of the Open University of Sri Lanka as a professor in environmental engineering. With that note, I would like to hand over this session to Professor Banduni Athapattu to moderate. Over to you, madam.
Thank you very much, Tilina. Thank you very much for your kind comparing, as well as, can you hear me, all of you?
Yeah, we can hear you. Yeah,
okay. Thank you very much. And so first of all, I'm so grateful to Professor Jayanta Bisekara and Dr. Jayanta Siranayaka, Dr. Mrs. Engineer Bhadra Kamaladasa, as well as Chamari and Engineer Kanti and Stashani. Thank you very much. And now onwards that we are moving to our question and answering sessions. I have several questions. I have seen that several questions are there from our audience, and many questions at the beginning was forwarded to Professor Jayanta Bisekara. So shall we? I hope that all of you have listened very carefully what they were saying. At the beginning, we started what is salinity, and also then we experience on what are the things at the in Sri Lanka, means how many problems we are facing, and what remedial actions we have taken, especially from the Department of Irrigation. And we moved into the rice crops and other crops that what we can grow in the salinity with the salinized soil, as well as Professor Chamri explained that how we can improve more varieties through biotechnology. So first of all, that I'd like to, first of all, and actually I'm so happy to see Professor Jayanta still is waking up, and I think its time is around midnight, past midnight probably. And so that I'm forwarding for very few questions to you from the audience, what I have noted down. And some are asking like this, let's say, right. First question, so that some ask that what kind of rainfall, like intense or long, helps to reduce the soil salinity?
Yeah, I try to answer that, without knowing the exact ground condition. I cannot give a, analytic or quantitative answer, but I would say long duration with intensity just about equal to saturated soil permeability. The idea is to recharge as much as possible. That's kind of what I would think as the answer to that question.
Okay, the next question also, are there any economical methods to control the salinity via seepage?
I don't know what the question, I wasn't clear about that question, the seepage.
So probably it's kind of like, the seepage is coming to the paddy fields, and therefore the question probably focused on whether there are any economical methods, like let's say like a riverbank, piling at the riverbanks or something like that.
Yeah.
Probably they are querying.
Yeah, I mean, one option is, when you get, I don't know, I'm thinking out loud without exactly understanding the question, but, you have very heavy rainfall periods. If there is a way to store that water and basically, recharge those fields, in between using that excess water, that's one thing I could think of. I'm not sure how seepage could help in that, but maybe basically flood the area with excess water to leach out the salts.
Okay, sir, and right. Okay, next question is kind of, there are several questions. What kind of rainfall index that he asked already, at what degrees of global warming and soil salinity is correlated for that particular rainfall?
That's a tough one, global warming and salinity, two ends of the spectrum. But, I think if it is saltwater intrusion due to sea level rise, obviously it has been accelerating lately, and global warming, we're trying to get the world to agree to 2 degrees warming, and that would be a good start, but I don't think we're going to get there. There's no agreement on that. So to maintain the current rate without seeing any acceleration, I mean, that one is also hard to answer because global warming and salinity are kind of two ends of a spectrum.
Right. The next one is, please explain what does it mean by adaptation action for this
area? Yeah, that's a good question. I mean, hearing to all this talk, I didn't realize this, salinity is a huge problem in Sri Lanka. It could be, due to various reasons, but on the coastal areas, for example, the sea level rise or saltwater intrusion through rivers, the idea of adaptation action area, which is something that's being used in US or actually in Florida, the government has recognized this is an area that's affected by climate change. So they designate a certain community or municipality or region as adaptation action area, where the local governments are allowed to pass some land use laws or policies, and perhaps make funding available to implement adaptation strategies. So it's basically identifying that area as a special, area that requires special attention and provide funding. For example, if it is frequently flooded, maybe the local government will come up with a law that says you can't build in the first floor. You have to have a house pad elevation at a certain height, for example. So basically allowing the local governments to implement.
My question is, now this whole workshop is for them to understand and get the technical skills, right? Like the purpose of sending them to these places is to get some technical points. Like we taking them to the agriculture department, there are so many things to see, of course, but is that the idea of this workshop?
Yeah, definitely. We have to draw the line between whatever the things that we need them to know, the technical things, as you said, right? Yeah.
So Shantima, that from where you are talking, that I'm not sure why you are. Are you asking?
I think there's another conversation going on.
Yeah.
Sorry, that I thought that she was the person who asked the question.
Yeah, even I thought the same. She's from Peradeniya, I think UOP.
Muted.
Maybe it's some other conversation.
Please. The next one is
Dr. Banduni, may I intervene for a while? I'm this Kamala Dasa.
Yes.
Just for the adaptation, to quote one example, in Gaul district irrigation department, with the intervention of the irrigation department recently, successful Sojan method was introduced. I'm not going into the detail, but you can see in the internet very few examples how this salinity affected areas were converted into the Sojan method. And earlier it were that were paddy fields, but now it can be used as a productive some other crops. I think it will be a good example for adaptation. We can go on, because nearly 50,000 acres in the coastal area have been abandoned by now due to various reasons. I am not going to say it is purely on salinity, but due to other social issues also. But that land can be used productively by converting that, using that sort of adaptation. Thank you.
Thank you, Madam. The next one is to Engineer Chandralata, that what is salinity barrier? So are you going to answer for that, Kanti?
Yes. Salinity barrier is actually gated structure. The salinity barrier is a barrier which that saltwater wedge going to the river is cut off. Somewhere the suitable places we cut off the salinity wedge in the river. It can be a permanent structure. It can be a temporary structure. In our presentation, we shows that using the sandbag, we put whenever necessary, we put the sandbag and temporarily give the solution. Actually, these structures is create the flood. That is our main critical problem. Which height is, how much open the gate, and those are the things we have to seriously consider because of the flood. However, we have to manage with the saltwater wedge also. Temporary, therefore we go to temporary solution with the sandbag. Other one is we saw that Gingangan Nilwalaganga is under construction. Wallery, Ganga, kind of things, we put the permanent solution, gated structures.
Okay, thank you very much. So do you have anything to add for the sanitary barriers in developed countries, Professor Jayanta?
Yeah, I think, Engineer Kamadasa mentioned it correctly. So it's a balance between, mitigating the movement of the saltwater front and making sure you don't affect the flood protection for the upstream area. So what we have is a gated structure where it is operated during rain events to let the water out, but it usually during the dry season, it's kept closed to maintain the water level upstream at a certain height to mitigate the movement or prevent the movement of the saltwater front. So it's basically a gated gravity structure, and that's what is being used. The problem is if you don't design it for sea level rise, they will be obsolete, which in our case, for example, here, many gates, you cannot open them for 2 hours a day during high tide. So you really have to design for under future condition based on the sea level rise projections.
So then related to that answer, the next question is, where can I remember asking, where can I get salinity data, ideally a salinity map, especially for the intense paddy cultivating areas? What is the range, and are there annual patterns like that? Yes, actually, so said that.
Probably somebody else, right? Talking about the inland areas.
Yeah, inland areas. According to sea level rise, that the map was developed by Mr. Bandulu Vikramarachchi, but only for the coastal.
Right, that's a surface flooding. We have, through modeling, we have developed the saltwater intrusion maps under sea level rise condition. I showed one example of that. The only way to do that to me is to develop some, groundwater models, which simulate the saltwater intrusion under sea level rise scenarios.
Okay. The same time, is it okay that if I ask you that if the NSF engineers and irrigation and also the universities, if they are willing to make such kind of map? I think we don't have at present, isn't it, Madam, who are from irrigation department? Do we have? I know about this Mr. Vikramarachchi's map, and he developed for his PhD program as well as once he is working at the CC Coast Conservation Department. And anybody else? Sometimes
Dr. Banduni, there is no such a map at the moment. Definitely, we have to develop it because it is not only the irrigation department that involves with this saltwater intrusion schemes now. Provincial councils are also now responsible, especially after the 13th Amendment. Some of the river basins and also especially the drainage basins are handed over to them. So now we have to get, all together to develop because most of the salinity barriers and the schemes, the salinity exclusion schemes developed by the irrigation department were handed over to the provincial councils, which are under control by them. So I think we have to all get together and develop a map with all this information. It's a very timely action.
Banduni, I think first thing, what is needed is a national monitoring network. Sure. I mean, maybe through the provincial council, just like irrigation department has the network of surface water monitoring. I think there needs to be a national salinity monitoring network along the coastlines and a national data set of digital elevation data, like what Mr. Vikramarachchi used for Galle area, that level of detail all around the coastal area. That's what I was thinking. Coastal region has to be identified as an area that is sensitive to climate change in particular. Even compared to the interior areas. because sea level rise is a reality and it's already happening. You saw that record from Male that I showed.
Yes. Mr. Banduliranachi, are you there to add something to our discussion? He was there. Mr. Banduliranachi?
Yeah, Dr. Malini.
Yeah,
actually,
please.
that was done with very high resolution data, because in coastal areas, we have done LiDAR data that the accuracy is about, their manufacturer's accuracy was about 30 centimeters, but it was checked and determined the accuracy is about the 7 centimeter level. So that was the advantage during that study, but that was only about covered only about 2 kilometers. So with that, we got a very high precise assessment on the coastal inundation. That was done with the support from actually JAXA.
I hope that this data, I think your findings are not shared yet.
Actually, that was done after the tsunami. After the tsunami, there was one Italian university supported the government who did that LiDAR data. That was covered about 2/3 of the country's coastline.
Okay.
That is available with the disaster management center. It was done to disaster management center.
Hi, Tuki. Thank you for your updates. And I think Dr. Jayanta Seranayake is saying that RRI mentioned about mapping of salinity. Dr. Jayanta Seranayake, that do you have something to add for that?
Because Mr. Sirisena and Dr. pulled together from our soil science division with the support from the University of Peradine, they are developing 1 kilometer square. They're taking 1 kilometer square. They are developing a salinity map for rice cultivation, and it will be unveiled very soon. I think within 3 to 4 months. They have already collected data.
Right, that is for rice crops. Means the crops means like the rice only.
Especially salinity map they will develop, but basically we will use it for the rice cultivation and other measurements and the other reclamation like that.
If I add that what Sojan method, what Madam Kamradasa said, are you advising to farmers to?
No, because in certain areas when acid pyrite is there, people they drop rice cultivation, instead they go for Sojan method. So you can see it in Bentota gold area like that. But in certain areas, we also feel that rather than trying to find varieties and according to we consider them as marginal lands like that, then it is better to go for Sojan methods in some cases, because you know that pH goes up to 1.2 like that. It's a very high acidity level, and therefore we also recommend that, and it is being practiced there. And we have some fields at Bentota Rice Research Institute also. If somebody wishes, somebody can go and see.
Yes. One of our students have visited there very recently, and they said they have done dosing, but the soil salinity is really high, and therefore whatever the crops they were selected were died off. So I think that we have to do much research on that. That's what I feel after hearing to those students. And if I go to the chat area now, means very few questions are there. That one is from Mr. Veera Ratna. What are the methods available that can be used to restore the lands affected by the salinity? First question. The second is how long it will take to flush salinity by rainfall after land is protected from salinity intrusion. I think Professor Jayanta, can you answer for that question?
Well, the only data I have is from that tsunami, with the saltwater flooding. Obviously, that's an extreme situation. It took several years, but unless we do some kind of analysis or modeling, it's kind of hard to give an estimate on that, I think.
So do we have models to use such kind of situations, especially for?
Pretty sure, I'm sure the agricultural modelers have those types of models. How long
agricultural modelers?
Yeah.
Right. That means Dr. Jan Seranayake should have to think of it then to add some models. And also regarding this, how long it will take to flush salinity by rainfall, that is like what Sir said, that the intensity of rainfall is the main problem for that. as you, so
I mean, if you
else
have, in the future, if you have heavy, intense rainfall, short duration, you know, that might not encourage recharge, for example, you know, it'll encourage more runoff. And so if you have lesser recharge, that might discourage, you know, cleansing the soils. But that's the only thing I could say.
Right. Dr. Nalin Vikramnaik, are you there? Dr. Nalin? Because he has done many work in the coast as well as salinity and the rainfall. That Nalin, do you have add something to our discussion? Maybe he has left, probably. Right. Any question? Because we have to finish our things before 12 p.m. And because we reserved our session up to 12. And any other questions anybody want to raise? From Professor Shamari, that she mentioned that lab scale experiments are going on to develop several varieties of after changing the biotechnology of particular through the biotechnology.
Yes, Dr. Atapat, I have some follow-up questions to most of the panels. Is it okay if I ask?
Please go ahead.
Yeah. To Professor Hettiarachchi. So I just directed my question in the chat box. So
yes, I can see that how accurate is Arabidopsis and rice?
Yeah, because I'm also working on rice, so in the drought tolerance. So there are too many homologs if you consider Arabidopsis and rice. So
yeah, so
how can you?
Arabidopsis and rice, it's like it belongs to two different families. But you need the Arabidopsis that we use as the model plant in molecular biological research.
Yeah.
So, so here that since the Arabidopsis now the both genome that has been already sequenced in Arabidopsis. That is why I told you in Arabidopsis.
My question is, so if you find one gene from Arabidopsis and you find maybe 3 homologs in rice, you just modify or transform all 3 genes, or just you select one candidate?
No, that so it depends on that the particular metabolic system or the regulatory system. But here then, because then if sometimes to get the correct effect, so we may need to co-transform several genes. Okay, so like the golden rice. So there they have transformed 3 genes to increase the vitamin A content. So there it depends with that the trait that we select and how many genes that they are involved. But here then we can use the knowledge that we already have with Arabidopsis because large number of research that has been done. And then using that, so we can identify the ortholog. It is not the homolog, it is the ortholog. The same gene from rice. Okay, so then we can do some modifications with those without taking some other sources. Okay, so I don't know, did I answer
So I have one more comment.
Yes.
I have one more comment. So in your presentation, you mentioned most of the mentions are transgenic. So I believe it's better to update with cisgenics, right? After 2015, introduction of CRISPR and many things going on. So I think the presentation
actually the CRISPR also used in this salt tolerance like as a gene editing technique. So there was a slide actually, so then I removed it.
So most of the slides are mentioning transgenics is bad, stuff like that. You know, after 2015, everything's changed, right? So I was expecting more updates on that, but okay. Anyway, it was
because then since I thought that the audience is mainly the engineers, then there was one slide and I removed while I was here. So on CRISPR.
So I have just last question to Dr. Senanaika. Is he available?
Yeah, I'm there.
So Dr. Senanaika, you mentioned that the developed variety from Pokali and BG variety, the salt tolerant variety have some problem with the yield and milling quality.
Yeah. It's what I want to tell you. Go ahead.
So about just one suggestion. So there are many accession, Japonica accession, they have weak lemma and palea. So why can't you introgress those genotypes into your salt tolerant variety so you can overcome the milling problem?
Yeah, it's also a good suggestion, but according to the knowledge which I have. Sometimes because almost all the rice varieties which we grow here, they belong to indica type. Yeah. When we cross with Japonica types, in some cases, they do not give these expected things, but it may be removed with the back cross breeding or moleculated breeding like that. We accept that it's a good suggestion anyway. So we are getting some these samples through ERI also. And then we do not worry about the origin, and definitely we are making some process. I think I mentioned it one slide also. It's a good suggestion. Thank you very much.
Yeah, just Dr. Bisekara, the question I asked about the salinity and the draft. So basically, we work. So now, actually, I'm working on tomato and rice. So we usually go for. Usually, we mention the climate change and crop breeding, right? When we breed a crop.
Mm-hmm.
So I'm concerning about the combination of these two may be affected the plant breeding programs. So that's why I asked the question.
Can you repeat the question again? I didn't get the two aspects you were mentioning.
Yeah. So usually when we propose a plant breeding program, usually we mention only the drought tolerance, usually.
Right.
Because of the climate change. But I was concerned whether the increasing heat and evaporation may increase the salinity of the crop, I mean the land.
Yeah, I mean, I think someone mentioned, with the increasing temperature, you have more evapotranspiration in some of the studies. And that means you have less water available in the soil. There's less recharge, or net recharge is less. And I would think that would increase the salinity.
Yeah.
So
that's why I asked whether we have to worry in the future breeding programs.
I think, yeah, exactly. I think you have to account for this warming that's already happening.
Okay. Thank you very much, Professor and Professor Adabot. Yeah.
You are muted, Banduni. Banduni, you are muted. Can't hear you. You are muted.
Okay. With this, Mr.
Professor Banduni, better.
Anybody wants to ask some questions? Now, I hope that you can hear me now. Yeah, Sujivan has stopped, and Sujivan mentioned that we have a little bit more time, so that's that it will not switch off at 12 p.m., 12 noon, so we can move a little bit further. Sujivan has stopped somewhere because how the engineers as well as the rice cultivators or the rice researchers coming together, and that's the place that we have to stop. So there that we have to have some kind of a policy for this country, let's say National Science Foundation, that they are going to give the leadership for that. So actually they are planning to have a kind of a wide policy on or the recommendation that can be prepared as a follow-up to this particular webinar. So that's what we were planning to have this webinar, to make such a policy or to the interaction between all researchers as well as engineers, and to do something to come out from the serious problem. So salinity is not only the coastal side, but we know as Dr. Sen said, it's kind of an inland salinity also another problem. So however, in future that we have to think about our crops and our food production and all the things. And so we have to go a little bit, we have to move forward in this particular situation. So if I'm asking from my last question to Ms. Kanti Chandrata, that do you have any other problems with this salinity? Because you are providing water for the irrigation or for other crops. So how you are going to motivate farmers to do some other varieties like what Sujivan said? You are just providing water, or that do you have any kind of interaction between the rice research or whatever the research organizations in the country about this food production?
Yeah, that was an excellent question. Thank you. I was about to ask it.
Kanti, are you there? Or I think Madam Kamaladas can also. Kanti, yes.
Actually, we are promoting there are organization with the farmers and officers. We are talking there. We are normally we are chatting with that the problems, and we aware the farmers. Now the problem is there, we have to go for another varieties and other things. Especially they are counting with the money, how much they have to spend, then how much can get back. Always they are calculating that method. But in the cases as a country, we have to use these abundant lands, these abundant lands
in much productive manner.
Yes, much productive. But farmers are not willing to come to that point. That is the thing. But somewhere that is also depends on some farmers. Farm organization are strong. They are doing those things and those things. Actually, my suggestion is we have to go. We have to first map the land use map. Then some area we can go rice, some coconut, some cinnamon, like that. That cinnamon is the best plant for the that inundation area. But there are no policy. We can't change the crops pattern. It is difficult to change the crops pattern. We have to go for that policy also to those things. Actually, when everybody, farmers, officers, that means government policies, if come together, we can success with this problem.
We can overcome this problem successfully.
Yes, successfully we can overcome.
Thank you very much. May I ask my last, getting something from Madam Kamaladasa, Madam Badra. You were the Director General of the Irrigation Department, and all this webinar, I think with your experience as a irrigation in the department, you can tell something about to all of us probably to go forward.
Yeah, Bandhuni, what I saw is actually in the webinar, it was mainly the discussion was especially from Dr. Jayanta Bisekara was explaining about the seawater intrusion and the effect on seawater. But according to Dr. Jayanta Senanayaka's presentation, he mentioned about the inland salinity effects as well in the agriculture sector. But now agriculture in the sphere of agriculture, we have reached the self-sufficiency in rice now. So now, as Kanti mentioned, we have to select the other varieties, other field crops that has export quality, and we have to have a combination of these things, considering the salinity mitigation along with the salinity mitigation measures. So that is the main contribution I can make towards agriculture. But the serious problem what I see at the moment the country faces is the drinking water. Because our main cities are, the located along the coastal line, and the domestic water and industrial water all depends on the water supply that's been extracted from the rivers and also from the ground level. So I think we have to address that issue very seriously, more than the agricultural sector. That is my view for the National Science Foundation and IESL to take this matter forward. Thank you.
Yes.
Yeah.
Thank you very
So
much.
Banduni,
Yes,
yeah, Banduni.
I'm forwarding to you, sir, that the way that we are talking about the groundwater
Yeah.
modeling you were talking about. So I think that you can tell us.
Yeah, I can suggest kind of early in the morning, but it's still my mind still works. Yeah, that's okay. I think I was curious. You know, this salinity problem is probably bigger than when I first started preparing for this talk. You know, I understand the saltwater intrusion due to sea level rise. I think the coastal areas are going to have a lot of issues, not only in agriculture, but also drinking water, because we have to depend on groundwater in the future. So a couple of things. I was wondering if there is so much water use in the upper parts of the watersheds. Now we are sending less and less water through the rivers, and that causes also migration of saltwater front. But I wonder if that exacerbates, which means we have to kind of store more water during wet times and use it not only for water supply locally, but also for environmental reasons. But one thing I thought NSF could do is, there should be a white paper of some sort how to deal with this problem, not only along the coast, but also in the inland. What are the policies? What are the monitoring requirements? And what type of data that's needed to do the modeling? So I think there should be some white paper that should be taken up by the government for funding purposes by either combination of some government agencies or NSF itself. I think it's an area of national security in the sense, whether it's food or anyway. That's all what I have to say.
Thank you very much, sir. I think that we have to stop, because that's, I think, all of the participants, they are in the mind of what Professor Jayanta said, and he also gathered that what they do especially at the Florida State, and we know that we can't go every aspects what they do. Like sometimes we have to do pumping, but other times that we have to do some other actions altogether. Especially that we have to talk about this matter, or we have to bring this matter to forward with the support of NSF as well as IESL and SLAS or any other organization, even RRI and all the university academics. So from here, that now I'm handing over to Mr. Shantasri to carry forward that the other things. I think we had a very fruitful discussion, as well as same time I'm thanking my personal appreciation to a resource person, especially Professor Jayanta Bisekara. Now it's almost morning, that what he said. And Ms. Kanti, as Madam Kamaladasa, and Dr. Jansen and Professor Shamari Hettiarachchi. Thank you very much. And we, this my personal thanks, but I'm handing over to Mr. Shantasri, from National Science Foundation, to carry forward this webinar, and thank you.
Yeah. Thank you, Professor Banduni. Before, how many minutes remaining? Can I know?
It's okay. We can go till 12:30. Yeah, you have enough time, so it will not.
Okay. Right. On behalf of the National Science Foundation, I would say before I conclude, I can say from the NSF side, maybe some questions in the chat box or some further questions. Anyone interested, you can drop me an email. My email is shanta@nsf.gov.lk. We can facilitate fully with our resource person. And also, as highlighted by the Professor Banduni, we are more than happy to take forward as a long-term partnership program, and to come up with sustainable solutions. To conclude, I can say from the beginning I saw the number of participants was steadily, exponentially increased up to the 100, I mean, somewhere to 120. Until the end, it was steadily with stayed around 100. That indicate, and also so many questions were in the chat box that indicate the interesting and importance of the topic. So to start, I would like to extend our sincere appreciation, Engineer Granny Jalap, Vice President of the IESL, and Professor Ranjit Senaratne, Chairman of the National Science Foundation, for delivering the opening remarks and paving the way forward to the next flow of the webinar. And next, our line of speakers, Engineer Kamaladasa, Professor Jayanta Bisekara, Engineer Chandralata, and Dr. Jayanta Senanayaka, and Professor Chamari Hettiarachi, all delivered, I mean, they touch upon wider spectrum from starting what is the magnitude of salinity, what are the causes, even some new aspects like compounding threat, like many aspects were touched upon. Even to me as a layman, even it touched upon the value chain. As a citizen, I have to look for, when I go to market, I have to look for some rice where salinity originated from salinity tolerant variety, which would contribute to the in a way solution to in future. So as highlighted, there were key highlights surfaced during the whole of discussion. We have taken down with full attention to all those recommendations, suggestions, comments, everything. To mention, to recap, maybe monitoring national network, kind of to monitoring the salinity levels and future scenarios, and also some kind of research and development, and kind of it was also very well highlighted that we can't tackle the mitigate the issue as an individual institution. We have to network together. It should be a collective and cohesive effort. So a National Science Foundation will do the networking and further taking forward the initiative to facilitate the issues and whatever the modalities to come up with sustainable solutions. So we will, next step will be to draft kind of a white paper, maybe a policy brief that will be together with the ISL, SLAS and the NSF, which will be the working document for future follow-ups. So with that, I can say, I can conclude with confidence. Today webinar, objective of today webinar was well achieved. And my special thank go to Professor Banduni, because our initial discussions was with NSF and you were the conduit. I mean, building the partnership with the NSF, ISL and SLAS, that leverage and complementary and synergy created, which was bring to this webinar to this, I mean, greater height. So future also look forward to such collaborative and partnering effort. And thank you very much, our sincere appreciation. Of course, our special thanks to Professor Jayanta Bisekara, I think in after midnight, I think in the early morning for you. Thank you very much for your enthusiasm. We hope your kindness. Thank for all and nice day.
Bye, everybody. Bye.
Thank you very much, sir.
Okay,
thank you very much
bye.
to all of you. So we are ending our webinar now. And thank you, Tilina. So I think we can pause now.
Oh, so we we can stop here. Professor Banduni, now I think we can let our participants know that there will be more webinars coming in the pipeline. So please be in touch. You can get knowledge on different aspects. In the future, we will announce them. Thank you.
Thank you, Tirina. Thank you very much.
Thank you.